I should start now so I don't forget. Good morning. We're going to start in a couple of minutes. All right. And it's 12:05. Let me check. We have 39 participants, so it hasn't grown very fast since the last time I checked. Let me check that I have the critical people that I need from the observing strategy team and from the SCOC to start. I think we can start. So, hello. Welcome to the second day of this third SCOC community workshop. Today on the agenda, we have the first couple of hours for discussion, for presentations and discussion of the plan for the SCOC to finalize the recommendations that we presented yesterday and through the next year, how we'll operate. I will present the new members of the SCOC. And in the second, after the break, which is at 10:30 through 10:45 Pacific, we have community feedback. So we asked you to report your impressions on our current recommendations and simulations, whether they're impressions that you collected before or during the workshop yesterday. As you hopefully has seen, I assigned slots to the 8 science collaboration breakout rooms. The breakout rooms were organized roughly by science collaborations. There are some exceptions. I hope those don't create confusion. I'm going to screen share the Slack message and let me know if this is still agreeable with you in terms of schedule. So we start at 10:45. And this is the lineup. So we asked that each group, there are actually 7 groups and 2 hours and 17 minutes. One group didn't need to present. So 7, and you have roughly 17 minutes in addition to what we had, to what I had said earlier. So if there are any issues with this lineup, just reach out to me in the break. And I will arrange changes. Just to lift any potential pressure. We do not expect this to be a formal presentation, though it can very well be if you have a formal presentations. If you just want to share slides, if you don't want to share slides, we want to make it as actionable and practical as it can be for you and your group. But we do want to hear what each group thinks about the simulations and the recommendations that we have presented. Are there any questions about this part of the plan? Or any concerns or requests for modification? All right. So for the first hour and a half, we'll talk about the process of the SCOC. Following an explicit request yesterday, we'll go again over the recommendations to clarify how much input we need on every piece of the recommendation. I will screen share and I will lead this conversation, but I want to invite all of my SCOC members to please contribute any moment that they feel like they can contribute to this. So that's what I want to do. Do you see my slides and do you see them in full screen?
Yep, looks good.
Thank you. I will minimize the window, so I will not see you all. I'll keep the chat here, so I'll see if there are things in the chat, but I likely will not react to it. So if my SCOC and survey strategy collaborators can take care of the chat and the Slack questions, and anybody that wants to interrupt, especially if what I'm saying is not clear, please do so at any time. All right. So the first thing that I want to do, this is what we're gonna do now. I'm gonna present the composition of the SCOC into 2023. We're gonna talk about how we plan to finalize the remaining questions and what the timeline is to finalize the remaining questions and details of the survey strategy, which will include discussing how we're gonna work with the early science team. And then I'll go question by question and discuss each one of them and try to highlight which piece of the question still require input at this time, which piece of the question may require input in the future, which piece of the questions we believe are quite final at this stage. And then I have a list of topics that were proposed by registrants through the registration form. I think these questions, the slides that I've prepared cover most of them, but I want to, if anybody wants to bring them back up, I'll go quickly through them and see if I think that there is anything to add based on what we say in the first part. But if anybody feels like those questions were not addressed at that point, please, we can bring them back. All right, so this is the membership of the committee. This is the same slide that I've showed yesterday, again, with a huge thank you to all the members that have contributed. These people have worked on this project for about 2 years, and it has been very intense labor and very difficult work of optimizing an extremely complex and broad space of scientific priorities and survey parameters. So again, my gratitude goes to them, and to all of you who have contributed and make their work possible by contributing science insight, whether through white papers, cadence note, communication with us, or through the metrics. So about a half of the members of this committee are about to step down at the 2-year benchmark of their service. And these are the people that are going to step down. So I would like us to share a virtual or physical round of applause to all these people that have worked really tirelessly on this project. So thank you so much to each of you. We will, you know, you are unreplaceable, and we're working very hard to find people that can fill your shoes. And for each one of you, the shoes are enormous to fill. Although I do feel that we have found a great lineup of people to rotate in. I see there is something in the chat. If anybody wants to interrupt, please feel free. So these are the name of the new people that will join the committee starting on January 1st, 2023. And this is the first time anyone sees that. So this is a brand new announcement. I will read their names. So Timo Anguita, Sarah Abjar, Rachel Mandelbaum, Adam Miller, Stephen Smart, Rachel Street, and Kat Vault will join the SCOC on January 1st, 2023. Will serve jointly with the members that are staying on the SCOC, Franz Bartnu, Olsen, Collins, Slater, and Jay Strader, as well as Lynn Jones and myself as ex officio non-voting members. We do believe that these people are going to be amazing in this position. We do believe we have covered a breadth of expertise across science domains that is extremely significant. And we believe that we have recruited people that will be effective members of the SCOC, effective decision makers, as well as effective liaisons with the community. I want to disclose that we are actually looking for one potential member to be added to this list to cover some scientific areas where we don't feel we might be as strong as we should be. Pending that, this is the composition of the committee. And perhaps I would like you to join me in thanking these people for agreeing to serve on this committee. And I would like to share an applause to them and to the outgoing members, and actually maybe pause to see if there are any questions on this. Meg.
I know the answer to this question, but other people might not. What is the term for the SCOC members? So these people start in January. How long does this term go for? Just maybe worth mentioning.
It's a 2-year term, and we have staggered the members of the committee so that the the members that are staying on the committee, we expect will stay for another year. And then we'll recruit new members because this is a standing committee in operation that allows us to provide continuity and share knowledge by having a half of the committee members staying on and a half rotating out. But it's a 2-year term committee at this time. And the committee is charged by the SAC, and the members of the committee, the people that are recruited into the committee, the nominations are provided by the SAC, Science Advisory Committee.
Fed, for the new members, you may want to say the areas of expertise.
Right. So I was thinking about whether I wanted to link them to the science collaborations altogether, but I don't want to do that yet because perhaps there might be some flexibility in some discussions. But Timo Anguita is an expert in strong lensing. So Rabja is a cosmology on the time and a time domain expert. Rachel Mandelbaum is a weak lensing and cosmology expert. Adam Miller is a transient expert. Stephen Smart is a transient expert. Rachel Street is a galaxy a Milky Way and transient experts, and Kat Volt is a planetary scientist. They serve jointly with the existing members of the committee that are already assigned to science collaborations. Franz Bauer is an AGN expert. Knut Olsen is a Milky Way expert. Colin Slater and Jay Strader as well, Milky Way experts. And they're assigned to the AGN science collaboration, the STAS Milky Way local volume science collaboration, the TVS science collaborations, and the STAS Milky Way local volume science collaboration, respectively. And I should say that Colin's expertise straddle transients and galaxy. Did I do justice to those of you, to all of you? And we will assign them, of course, to science collaborations based on their expertise and connections with the science collaborations. And I don't see any further hands raised. So with that, I'll move on to talking about the remaining points to be finalized in our recommendation, and how we plan on getting feedback, and how we expect to solicit feedback, and on what. I'm bringing back this slide. This is just a dump of the community post that Lynn had released when she released the four simulations that constitute version 2.99. I highlighted some of the key points in the description that kind of cover the 8 questions that the science collaborations has organized its deliberation around and organized, split into subgroups to address. So we do have the simulations already have a lot of the recommendations implemented. For example, our current recommendation on the strength and number of bands for rolling, our current recommendation for microsurveys, our current but perhaps not final recommendation on the footprint and filter balance on the galactic plane, etc. And like we said, we have 4 simulations because we're still stretching some of the parameters and testing how varying them impacts science overall in this global optimization that will lead to the most effective science throughput for Rubin altogether. And some of the parameters that we have stretched, so clearly those are things that we're working on, are the amount of time that is being spent on the deep drilling fields. I have a lot more to say about the deep drilling fields and what it is that we still need to optimize about them. The amount of time that is spent on the galactic plane and also the footprint on the galactic plane are still under considerations, and this particularly tricky balance of how what we set up for the repeat of observations, so the time gap, the intranight time gaps, and how that gets controlled by a number of the features and the parameters that that we input in our simulations and ultimately into our scheduler, including the specific characteristics of the rolling cadence and other parameters that control the time gaps. So those are the things we are working on. The slides that I'm going to use, before I get to that, I want to point out that, of course, there are going to be updates to the simulations. Even if we had a simulation, a single simulation, and we had settled on all of the decisions that we want to make, there still would need to be updates to the simulations. The updates would refer to inputting in the simulation the characteristics of the system as built, which are over time becoming known to us all and you. So the simulation will be modified. Even if we left all the parameters in the OpSim the same, the simulations would change. And we will reevaluate these simulations and whether or not they correspond to the letter and to the intent of our recommendation as we make these changes. In 2023, we're going to include the system response, the response of the system as built, including the actually measured transmission curves of the filter and of the system, entirely encoding and reflectivity, etc. This can be included earlier. The transmission curve, for example, are already available and will be updated at the beginning of the year. Some of the information about the system will only become available during commissioning, and there were questions on Slack about this. The timing of this information will range. For example, things like saturation limits will become known early in commissioning. Most of the knowledge and most of the information that we need to measure them is already there. There will be decisions that will be made in commissioning, including a critical decision for survey strategy, which is whether we will continue to use 2 15-second snaps for each exposure, or we'll move to 1 30-second snap, 1 30-second exposure. This decision will be made in commissioning, and it's a decision that will consider both technical and scientific input of this choice. And this will have a significant impact on our recommendations and simulations, because the efficiency of the survey altogether changes by 7%. Lynn, Peter, please correct me if I'm wrong. I think the number I have in my head is 7%, but anyhow, somewhere between a few and several percent, which is a lot of time. It's 2 TO and then some, 2 TO programs and then some, right? It's a couple of microsurveys. So this will be an impactful decision, and we do not know yet where this will be settled on.
It's actually even I would say it's between 7 and 9% fed. So it's almost like a whole extra year of LSST.
Right. Right. Thank you for adding accuracy to my number. So this is being discussed regularly in the data management team, in the commissioning team, but we will not have this decision until we go on Sky with commission. All right. So I basically stole the slides that Lynn made yesterday. I just added some more specific text about what input we're looking for on what timescales and from whom. But thank you, Lynn, again for making an amazing slide deck yesterday that made this very easy for me to respond to the request to be more specific about all this. So these are the same questions as before. I actually ordered them slightly differently even than this slide, but forgot to update that slide. But let's start. I'm kind of following the same scheme, right? Starting with the things that are less complex and for which it's less complex to communicate to you what we need and when, if anything, and going into more complex discussions. So a really easy one. It's not easy to know how we'll address this question, but it's easy for me now to tell you that at this stage, we are making a plan for addressing early science, but we are not actively addressing early science at this moment. I want to point you again to RTN 011, which came out just last week. Is an update to the plan for early science. And we have specific text in it that refers to the Survey Cadence Optimization Committee and the shared responsibility on early science that the early science team and the Survey Cadence Optimization Committee share. I will not read the text to you. Well, I read some of the text to you. The text that we have is that optimizing the LSST year one observing schedule. Sorry, let me point out early science is beyond year one, but the purview of this committee is to address year one. Early science also addresses commissioning and science verification. But optimizing LSST year one observing schedule to maximize early science may mean that the time sampling in the LSST survey region looks somewhat different to that in subsequent years. One of the tasks of the Rubin Survey Strategy Optimization Committee is to make specific recommendation for these early survey observations in terms of the prioritization of sky coverage and other specific choices needed for year one. Producing a meaningful and informed recommendation that can be implemented effectively will require the SCOC to interact closely with the Rubin commissioning and operations team so as to allow the time for those interactions. The early science recommendation will be deferred until 2023. So that is to say, at this stage, we're not actively collecting input about early science, but we are making a plan for shared responsibilities and how to work together with the early science team. And at that point, we will explicitly solicit input and tell you in which forms we seek your input. Any questions on this? I also want to point you to the most recent talk about early science, which was delivered by Liang Gai at LSST at Europe 4. There's a link there on the slides to her slide deck. I can also put a link to the video that will be uploaded today on the YouTube of the LSST at 4 conference, LSST at Europe 4 conference. All right. Another one that is fairly easy to describe is microsurvey, but this will take some time, and I would like to invite Jay to speak. Jay was chairing the subcommittee that started the deliberation on this question. I would like to invite you to chip in at any point in this. Overall, we have a recommendation which we consider fairly finalized, and because we have decided that our recommendation for microsurvey will be limited to what is being done in year one. Why? Because we have large uncertainty on the efficiency of the survey that would, like we said a few minutes ago when we talked about the decision between 2 snaps and 1 exposure, may allow to include significant more time for microsurvey or significantly less time for microsurveys. Therefore, at this stage, we cannot commit to anything other than what could be implemented and could be implemented in year one, and we only recommend implementation of surveys for year one. With the criteria that were described yesterday by Lynn, through which we had about 10 proposals for microsurveys that were received through primarily through the cadence notes. Of those 10, there were also some proposals for let me define a microsurvey. It's a survey that takes only a few percent of the time, 3% or less. There's also the concept, or at least I've seen references to also even shorter surveys that take even shorter amount of time, nano surveys that might take less, like a fraction of a percent. At this stage, with the uncertainty on efficiency, given by the fact that we don't know the system as built, we haven't worked on evaluating the nano surveys. We believe that this should be done only once we have more information on the efficiency of the system. Of the 10 or so microsurvey proposals that we received, for each one, we look whether they met 3 criteria. The first criterion is the scientific relevance. That's easy. That's our job on many committees to do so. The second criterion is whether they exploit the specific characteristics of Rubin such that they could not be done by another telescope or another survey, and they really take advantage of the thing that Rubin LSST is good at and is designed for. And the third criterion, because we're only recommending surveys in year one, is that they are time sensitive at this time. There is a specific reason, or rather, there is a specific scientific loss if the start of the survey is delayed past year one. Having looked at all the 10 proposals in the light of these 3 criteria, the SCOC found that only 2 met all 3 criteria and 1 more specifically than the other. So the SCOC recommends that the NEO microsurvey starts in year 1. We consider this recommendation finalized, but the details of that survey might need a little bit more input from the community as to how we really implement that survey. The other survey that might start, depending on whether enough time is available to perform more than one microsurvey in year 1, is an Earth Stripes microsurvey. What does it mean for the other microsurveys? It's not that we think that there is a tremendous amount of science that can be done through many of the other microsurveys. We just do not think that it should be done in year 1 and prioritize over these 2 surveys and over other priorities for year 1. We also want to acknowledge that we do believe that Rubin is a transformational survey and it will transform the landscape of science going forward. So we need to have a plan to make space for more ideas to come in that might become priorities over time. So what we envision at this time is that in 2023, the SCOC will work with operation and set up a call for microsurveys after the start of operation. This is not a call for only new microsurvey, but also a call for reproposing the microsurveys that have been proposed, and our report will include specific details on how we felt that a proposal had not met any of the 3 criteria and which one of them. So the report will contain information that will help you strengthen your proposal against these now public evaluation criteria, as well as enable the consideration of more science to be done with microsurveys. I want to pause, and before I ask if there are any questions, I want to ask Jay if you want to add anything, or anybody else from the SCOC actually.
Yeah, the only thing I would add, right, is that, right, for consideration of the microsurveys proposals, we sometimes merged ones. So the number of proposals written that actually had microsurveys was much larger than 10. This is what we wound up with once, we excluded the nano surveys, and then there were some surveys proposed which were much larger than microsurveys, right? So they asked, 10% of LSST time. And those were considered in different ways. For example, they were factored into the galactic plane or bulge considerations. So.
Thank you. Yes. And if there are any specific questions about this, maybe we can, about your microsurvey, if you want to ask us about your microsurvey, absolutely, we're open to that, and maybe we can defer that to the community discussion later or the break. I may be available for most of the break. Meg.
So I'm not wearing my SCOC hat, I'm wearing my science collaboration hat on. So it's great that the microsurvey for NEO Twilight is recommended. There is some uncertainty about what's being produced in December versus when the final report is, et cetera, which I know will get clarified later. But I want to point something out of that these microsurveys do need money and people to do things. And so how do we I want to just point out, how do we go to an agency and say, this is going to happen if things are in draft or something else, because it's not final and people don't understand that, right? So how do I go to NASA and say, we should do this, it's planetary defense, pay for it? And they might go, that's still a draft recommendation because the cadence hasn't been finalized, so it could change. And so I don't know what the answer to this is, but I just wanted to raise it that now that we have this, the first thing would be is people going, great, this might not need, the SSP might not be able to do this. We might need to write something. How do we go and say, look, it's going to happen, so it's a guarantee, right? How do we apply for money? And so just to raise that, because people will be applying, next year to start actioning for the start of operations. That's
a really good point. I hadn't put a lot of thought, actually, I hadn't put any thought into it yet. It hadn't occurred to me, and it's a really good point. So it's obviously a discussion for the SCOC to be had, but I'm sure that there are going to be ways to indicate that although altogether we don't have a final altogether recommendation, we do have some firm pieces of that recommendation in a way that is visible to the agencies and to the funding bodies and to the people that review our proposals. That's a great point. Thank you. Anything else? All right. part of the reason why the count 10 was part of what Jay clarified, or an example of what Jay clarified. The TOs, technically they're a microsurvey by the definition that I gave you earlier, which is less than 3% or less of the time. We actually had a separate set of considerations and a separate subgroup that evaluated TO as a microsurvey. So at this stage, we recommend an envelope of time for TO, and the envelope of time is very well defined by the community studies that we have seen, including and specifically Margutti 2018 white paper and Andreoni 2022 Astrophysical Journal supplements paper. They make a very clear and detailed and data-driven case, or science-driven, science and data-driven case for why a fraction of time of about 2 to 3% of the survey would be sufficient to enable a very good program for TOs. Also, I would be remiss if I didn't admit that there is a lot of uncertainty about gravitational wave counterpart science, since we have very few single one, maybe one example of it, and the LIGO Virgo runs continue to change, and so it was very clear from the beginning, and it's a charge of the SCOC from the beginning, that the TO program gets reevaluated every year to see how it needs to be changed in the landscape of probably very rapidly evolving gravitational wave and multi-messenger astronomy science. So this is our initial recommendation to enable something of the order of 2 or 3% of time for TOs. But the details of how the TOs are to be performed, those are more complex, and we do not have a recommendation at this time. This includes how do we choose the targets, and what strategy to implement for each target specifically based on its characteristics, which filters to use, and what is the follow-up, what should the follow-up specifically be designed like, how many days after the trigger we need to follow up, etc. We do have a set of recommendations that is very clear in the 2 papers that I'm mentioning above, but those are only community driven. And what we need is to bring the community, the experts on the science that can guide us on how to design the follow-up, together with the observatory and SCOC members, to understand better what is possible and what is feasible and what is optimal for the observatory and for Rubin science altogether. So we plan on setting up this decision in spring 2023 through the current plan is to have a workshop where the member of the community are invited to come, and member of the observatories will be present, as well as members of the SCOC. And that in this workshop, we hope we can deliver a recommendation in the form of a white paper that is detailed about how the TOs get implemented in practice. And I want to add that people who are probably here, I don't know, I didn't check if I saw Tiago here this morning, but he was here yesterday, and he's signed up for this workshop, are already working on the implementation, right? So we're already working on how do we get the alerts, how do we respond to the alerts. We're planning on responding to the alerts with Oxtel as an exercise. And so this is already work that is ongoing on the observatory side, but we need to bring together the observatory and the community to finalize the details of this recommendation. I'm going to pause for questions. Mansi.
Yeah, just to clarify, Fed, since our last SCOC discussion on this, the 04 run got delayed, and it's going to start in March. So we might have to delay this workshop also, so that there is a few months of 04 to drive the scientific input into the workshop. But yeah, I mean, there's always, push and pull to figure out a date. But it might not be April, right? I mean, it might be, yeah.
This has been brought up, so tentative April, but it is tentative. We're definitely still talking about it, right? There are pros and cons of waiting and of doing it early, and also maybe the format of the workshop can be massaged in such a way that is that the fact that it's joined with 04 is not disruptive, etc. But yes, it's definitely a tentative. Igor, then Jay, then Graham.
Yeah, I would like to bring forward the question that I was asked by other people in the community that are not present today, which is about basically data management for TOOs, which I think is a type of discussion that goes in parallel to what the strategy is. So in particular, people are interested to know to who and when data will be public. Is this something you already know something about, or just to be discussed at a later stage?
So I don't want to discuss data products and data releases at this workshop, primarily because even though I saw some questions on the registration form about it, primarily because it's not my purview and I would want to make sure that I have the right people to discuss this. So, but you know, TOs will be released publicly. They're part of the alert system. So I don't expect things to be substantially different in terms of data management and data processing. That's exactly the reason why we need to bring the observatory and the community people together to talk about what is possible and you know, what is optimal, what is needed, and what is possible, and see how we can set up the system for these things. So I don't have an answer for you, but I think that this is exactly the kind of thing that can be defined in this kind of workshop where the two communities that know the two pieces of the story can come together. Is that enough, Igor?
Yeah, totally. And also just pointing out that Eric has just sent a useful link. I just guess this sort of matter keep evolving so quickly. So it's good to hear the latest. Thanks, Fed.
Awesome. Jay and then Grant.
Yeah, I just wanted to, I also said this in Slack. TOs are not going to be limited to gravitational wave sources, right? That's not like a predetermined decision. So people can, you know, make science cases to do anything as a TO, but it has to take advantage of Rubin's unique characteristics, you know, which giant on 10 do.
Yeah, and to that, let me add, we're kind of I think it makes sense to design the TO program thinking about the gravitational waves. We have enough information that can lead into the design of a program like this, right? And there is an obvious, clear scientific motivation for doing it. There are other phenomena that might work very well with this design, including other multi-messenger astronomy science driver like neutrinos and things like that we may respond to within the same framework. There may be other kinds of TOs. Once we have a TO program set up, we can think about what are the things that are worth using Rubin for. But like Jay said, they would need to, there's very obvious case why Rubin would be good at gravitational wave. TO, there isn't an obvious case that it would be good at this stage on other science TOs. Grant.
Thanks, Fed. Hi, everyone. Just a quick question about the workshop then. Is the idea that the participation in that workshop is to first order the Margutti 2018 white paper, Andreoni et al. 22, or is there opportunity for others to get involved?
I think anybody that is interested, and particularly anybody that is interested and has expertise such that they contribute, should be encouraged and supported to get involved until we know the details of what is the modality of the workshop, who's hosting the workshop, right? I cannot say anything else. And certainly we would want the people that have contributed to these two seminal papers to be at the workshop and taking an active and perhaps leadership role in organizing the workshop. But it's absolutely not limited to the people that were on this paper. And I want to add that Rafi is doing a tremendous job at putting together like really anybody that is interested in being involved in the counterparts characterization and multi-messenger astronomy within the science collaborations, and that there has been a renewed call to people in the entire community to join this group within TVS and just join the conversation and be part of it. Franz.
Just to follow up on that, nothing is written in stone, and a lot of the things that were suggested in those papers actually need to be revised anyway, will be revised, pared down. They don't need to be at the level they were proposed at. And, so there's lots of discussions and input is desired from all sides.
Yes, absolutely. I don't see any more hands up. Everything under control on Slack and chat. All right, I'm gonna move on. All right, so filter balance. We do feel like we have a good, solid recommendation for filter balance on the low dust, low extinction, wide, fast, deep footprint. We have presented this filter balance in the most recent simulations. It's actually the same that it was in the previous set of simulations. We thought it was optimal or near optimal and doesn't need to be there's no evidence that it needs any changes. At this stage, we're not seeking input on this, but this recommendation itself is based on a tremendous amount of input that the community has provided over years, literally, and many metrics that helped us come to this recommendation. Similarly, we believe the exposure time should be maintained 1 times 30 seconds in U band, and currently we have 2 times 15 seconds in the other band, which might become 1 times 30 seconds. We found no evidence in the many science metrics and also in your reports that indicated that this should be changed. So at this stage, we're recommending that the exposure time should be maintained, and we're not looking further input on this at this stage, meaning that we think that this recommendation is can be considered the final initial, as Bob has suggested to call it, the final recommendation for the initial LSST survey. However, both of these recommendations are susceptible to change if once we include the characteristics of the system as built, filter transmission, etc., we find out that this effectively changes the filter balance from what we have simulated until now, which we're going to simulate. Like I said, we're going to update our simulations with the system as built. We're going to look at all of the metrics again. We're going to see if there are any significant changes, and we might reopen this conversation if there are significant changes. A separate consideration is for the filter balance on the galactic planes. It was less clear to the SCN and the South Celestial pole. It was less clear to the SCOC what is optimal there, but this is, and we are seeking input, and we're looking to specifically work with the Galaxy community on finalizing the filter balance on the galactic plane footprint. We also do think that this is an easy achievable convergence for this piece of recommendation that also does not impact the rest of the wide, fast, deep. So it's a compartmentalized piece of recommendation that we think we might be able to achieve perhaps before December, hopefully before December. It might be after December, but we will achieve this and we'll look not only to input, but really to work together with the Galaxy community to get there. And I'm going to pause for questions and comments. Yes, Meg.
So I just want to look at community expectations, wearing my science collaboration hat on. To me, this 1 by 30 to 2 by 15 seconds happens in 2024, right? So is that correct, that you really need the actual camera on? So although you're saying these are later, this isn't a 2023, this is a 2024 decision. Is that right? I just want to make sure, like, get in my head what the SCOC is grappling with next year versus not. Mm-hmm. So it sounds like this is you need LSST cam on Sky. This is not a decision you make with ComCam.
This is a commissioning decision. I'm looking to see if there is somebody, this might be above my pay grade to decide which.
Right, or like the throughput on the filters, right? Like if or the changing the exposure time based on the full set of what you're getting in terms of limiting magnitudes, that's a 2024 decision, right? When you're really observing with LSST cam.
So the filter balance, the changes in filter balance, I would expect that the majority of, and Lynn, please help me out with this perhaps, I would expect that the majority of the changes would happen after we change the transmission curve for the filters and the coating of the mirror, and that will be the most significant, where we see the most significant changes. I do not expect that going from there to on sky, we would see significant changes on the transmission curves. Lynn, would you agree with that?
Maybe. I mean, I do think that there are a lot of other there are some other uncertainties. I do know that as we change what we expect to coat the mirrors with, we will see changes that we may want to counterbalance in the number of visits or the exposure time, or just take those changes and say this is bringing us closer back to the expected throughputs in the SRD, which actually I think that's what we will most likely see from the mirror coating changes. I haven't looked at the filter throughputs from the as-built filters, which we are just now starting to see some information to put into the system. I think when we get on sky, we'll also have more information about sky brightness at the site, and as well as like how things are actually working across the full focal plane. And so there may be some more changes. I think that I don't know if I can super well predict what it will be like when we get on sky, but like, yeah, I think like after the changes in the mirror coating, I think are almost are not that far out from getting an update. And so we should have updates on the filter curves and the mirror coating sometime in early next year. And so we can incorporate those, and that would be at some point like early or, at the latest mid next year, I would expect.
Right.
And then from there until like actual commissioning, I would expect that to stay relatively stable. And then after we get information back from the actual camera and the actual site and the actual system, we'll have to have another look. And I don't know how big that change would be, but
okay, so it sounds like it would be an iterative process, but some of that process can be evaluated, and we can reopen these recommendation once we have the transmission curves, but we might need to do that again once we get on sky.
Yeah, that would be my understanding.
And Meg, was there another piece of question?
Nope, that was it.
The other piece of question was the decision about when does the decision about 15 versus 30 seconds happen, and whether it's commissioning or when we have the proper camera on. I don't know that I feel qualified to answer that. Željko is here. Željko, do you have an opinion on this? Can I put you on the spot?
Sure. We do plan at the PST, Project Science Team, to address this once we have commissioning data in hand, and probably ComCam will be sufficient to test whether we can find cosmic rays with adequate completeness using only one exposure. This split exposure was originally designed to find cosmic rays by subtracting two snaps, those two 15-second images, and then finding cosmic rays in difference image. However, at that time, we did not appreciate fully that with thick devices that we have, that cosmic rays will be more looking like worms than they looked in SDSS, like very narrow stars. In other words, it will be much easier to find them morphologically from one image than it was, for example, with SDSS and other surveys. So we do have some preliminary work based on convolutional neural networks that indicates it will be piece of cake to do so. But until we have real LSST data, we cannot say with certainty. So the plan is that during commissioning, we will get some two snap in an exposure data. Then we will process it both ways. We will do difference imaging on snaps, and we will also add them and then do morphological analysis. And we will see how well we can find cosmic rays. If we are correct that it will be easy and that we will have very high completeness, which means very low false positive rate for alert distribution, then we will say, okay, we are switching from 2 × 15 to 1 × 30, and we are saving about 7-8% of the observing time by that switch.
Thank you. I appreciate it. Right. Any other questions on this? I don't see any hands, so I'm gonna move forward. Footprint refinement, kind of similar to the filter balance. We think that the footprint on the wide, fast, deep, low extinction plane is close to optimal with the system performance, with the current system performance. So we recommend, we the SCOC recommend that it doesn't get changed from what it was set in version 2.0 simulations, and we are not looking for input, specific input at this time. Of course, let me qualify this by saying one thing. If you disagree, we are happy to hear your arguments at any time, but we're not looking for input. We believe that we have collected enough evidence and analyzed all the evidence that you have provided to come to this conclusion. Same for the time spent on the mini survey, the fraction of time spent on the mini survey, and I spoke about mini surveys already earlier. The details of the footprint on the galactic plane, those are being finalized. They've been changing quite dramatically from, if you think about it, from version 1.7 to version 2.0, and again to version 2.99. Thanks to enormous contributions from the community that has really helped optimizing the footprint on the galactic plane, and we have seen enormous improvements on galactic science from version 1.7 through version 2.99. We're seeking to still further refine this. There is there are considerations about the efficiency of the survey as well as the scientific throughput of a particular observing scheme to be made. So we seek to work together with the galactic community to come to this conclusion, to finalize this recommendation. Like before, this seems like something that we might be able to converge on before December, and we'll work towards that. Then again, we might not be able to, and if we are not, we'll continue working on it in 2023. Questions on this? I don't see any hands up. 3, 2, 1. All right. Deep drilling fields. Okay. One thing that I don't remember, I didn't notice yesterday. I was trying to answer questions on Slack a lot, so I might have missed that. If Peter or Lynn have explicitly pointed your attention to this, but I wanted to do that again. The one action of the SCOC earlier this year, in March of this year, was to endorse the Euclid Deep Field South as the 5th deep drilling fields of Rubin. So that field has been included in all of our simulations. You see it in all the 2.99 simulations at this point. Something to point out is that the Euclid Deep Field South actually has a larger footprint than the other deep drilling fields. It has about twice as much area. So it can be covered in 2 pointings. And our recommendation is to collectively observe it as a depth equal to the other deep drilling fields, or in other words, to observe each half of it to a half the depth. What input is needed to on this point? The field has been selected. We stand by this recommendation. We believe that it maximizes science altogether, but we do need input to schedule the observations on these deep drilling fields, and as I'll point out in a second, on all the deep drilling fields. And also something that was interestingly brought up during the LSST at Europe 4, we really need to make sure that there is support for the community to develop the joint data products that will make pursuing these deep drilling field worth it. We believe that there will be, but the plan for producing these joint data products, the plan for coordinated observing still has to be developed. By whom? By the Euclid and Ruby teams that have already worked together extremely effectively to produce the joint data product paper that came out in earlier this year that I probably should have put on these slides. Actually, it is on these slides because it's in the community post that I'm referring to in these slides. There is a much broader discussion about deep drilling fields. We are not ready. We don't really have a lot of detail and finalized recommendations about the deep drilling fields. The pointing of the deep drilling fields is set. For 4 deep drilling fields had been set for a long time. We added the Yukon deep drilling field south. We have noted that the 5% nominal fraction of time that will be spent on the deep drilling fields is unlikely to be sufficient to obtain a good throughput, particularly to obtain a good throughput for supernova type 1a cosmology science. But increasing this time has benefit for static sky science as well. So our recommendation is to increase the fraction of time that is spent on deep drilling fields to about 7 or 8%. And you've seen that already, because you've seen that our simulations are now at the 7% mark, and we have produced one simulation at the 5% mark just to test whether this recommendation is robust, and we believe it is. However, how to observe the deep drilling fields in detail is quite complex, and we are actively working with the communities that are most interested in deep drilling fields, including, and lately primarily, the supernova 1a cosmology community, to make sure that we have an internal cadence, so a repeat time between visits to the deep drilling fields that really supports transient science, in addition to having finite depth and reaching a specific depth at a specific benchmark in the survey for each deep drilling fields that supports static sky science. So we're still working with the community to understand how we should observe the deep drilling fields in terms of intra-night repeat. One thing that I forgot to mention is that another recommendation that the SCOC makes is to achieve 10-year deep drilling field depth early on at least one field, and that one field we further recommend that will be the Cosmos field. This will enable static sky scientists to prepare to really make the best of all of the deep drilling field science that will come in the 10 years. I'm going to pause for questions. No questions on this. I expected to spend a long time on this. Thank you, Mike.
Does that mean it only gets observed for 3 years into Cosmos, or is it observed longer? So do you get more than 10 years?
Yeah, I don't understand the question. I just don't remember at this time. So I'm going to call on my other SCOC members that are on the subcommittee for deep drilling fields to remind.
I think I know the answer, but I think I know what the answer is, but I don't want to say it because I'm not 100% sure. But maybe Lynn knows the answer to that one.
Lynn, what was the recommendation? I don't remember.
So the recommendation that we heard was that it should keep observing after that point. I think that this is one of those things, though, that there isn't necessarily a super clear answer for. And if see, the thing is, Cosmos is kind of is the deep drilling field that's a little bit off by itself. So it's easier to modify the observing strategy for that field. And perhaps doesn't make that much of an impact if you just keep observing after the first few years. But there may be some questions about, like, what do we gain from that that need to be weighed against, like, if we just did something else with that time. That I don't know if we have, that are the things that the SCOC need to weigh in on. And I think at this point that understanding that particular gain is more in the context of, well, the other deep drilling fields are going for the full time, and so it makes sense that this one has benefit to go for the full time. But really understanding what that is I don't know if I could point to the particular thing, and maybe somebody from the subgroup could.
And let me point out, as a reminder, that the SCOC is a standing committee into operations. So we will reevaluate year by year whether the survey is achieving the scientific goals that we want to achieve and is really optimized. So perhaps it would be fair that we have an initial recommendation that is susceptible to being revised. I see Philippe, and I also see Francis from the SCOC, and so he might have more insight onto this. But Francis, is it okay if Philippe asks his question first? No problem. Philippe.
Thank you. It's in fact a comment. So From the supernovae point of view, the goal is to observe cosmos only few years and not after that, because it does not help in getting better cosmological measurement.
Thank you. That's important insight. Franz?
Yeah, so the motivation was to go the full 10 years to retain all of the other transient science at a similar level. But there's nothing to actually say that all of the deep drilling fields should be the same. And in fact, one would like to probably use them to test different vectors of the survey completeness and so forth. And so actually going deeper in one than all the rest will benefit all of the rest of the DDFs and the entire wide fast deep. So that to me is one of the motivations that is fairly strong, that we shouldn't just all go to the same depth for all of them, but we should try and vary things a little bit.
Thank you. And Graham.
Hi again. I have a question about the cadence in the Cosmos deep drilling field. Does the positive impact of that on the type 1A discovery have any interplay with the discussions on or assessment of the different wide fast deep survey options, in terms of then the ultimately feeding through into the number of supernovae that are available for the cosmology studies? Does that make sense?
Yeah, I think I understand the question. So when please, anybody that wants to jump in, but when we look at the supernova 1A cosmology from the point of view of the SCOC, when we look at the metrics that reflect whether the supernova 1A cosmology is optimized, is good, is feasible, we do look at them for both the deep drilling fields and the wide fast deep, and we consider the importance of supernova type 1A cosmology in both fields, in both surveys, if I understood your question correctly. And actually, Saurabh has his hand up, and that's great because he might have some insight on this.
Yeah, the way we look at it is that there are actually two different science cases for the deep drilling field supernovae and the wide fast deep. Obviously, the wide fast deep will be many more objects, much bigger sky coverage, but generally lower redshift. And so the two main things that the DDF supernovae give is a leverage to higher redshift. So if we're looking at the change in the dark energy equation of state, that's quite important. And then also it'll be something of a calibration sample for wide fast deep, because we'll go so much deeper. We will basically have a complete sample in the DDFs compared to the Malmquist bias sample that you'd have in WFDs. So we can calibrate that Malmquist bias with the DDF sample, to the lower redshifts. So those are the two big drivers. You get more cosmology at higher redshift, and then also a better calibration of the wide fast deep sample.
Thank you, Saurabh, and thank you, Graham. Anything else? All right. What do we have? Okay, so this is the part that I think is more complicated to wrap at least for me, to wrap my head around, and to wrap my head around, just to wrap my head around. And also, sorry, my slides are a little bit ill-formatted here. I put them together. So the rolling cadence and the intra-night cadence really have a strong interplay. So those decisions, even though we've put them into two separate questions, those decisions have to be taken jointly and optimized jointly. The rolling cadence group has looked at the rolling cadence options. What we have analyzed are rolling cadences performed in 2-band, 3-band, 6-band. So that's the fraction, just to make sure that everybody is on board. A rolling cadence means you emphasize an area of the sky at some times to de-emphasize it at later times, so that you have a more compact cadence on that area on the times off, and a less compact cadence on that area on the times on. Altogether, you reach the same depth, but you obtain higher cadence on each area of the sky at some point in the survey. And then you can do that in different schemes and to different strengths. So when I talk about bands, it means how many area, into how many area do you split the sky to set this on-off pattern. And when I refer to the intensity is what is the fraction of time that you spend on the sky area that you're interested in versus off. With a caveat that when I say 0.9 strength, that actually doesn't linearly translate into 0.9 of the time on the area on and 0.1 on the area off. So just take those numbers as proportional to the strength, but not numerically representing the strength. So the considerations that go into this, how much rolling how much is the rolling scheme enhancing time domain science, particularly fast transients and time transients that are not very long in time scales will benefit from it, versus does it hurt long-term transients, and does it hurt the homogeneity of the data releases that you get every year, which is important for static sky science. So we're trying to reach a balance between homogeneous data releases, uniform data releases, and enhanced time domain science. So the 6 bands clearly doesn't do that. It clearly sets up far too much uniformity in the data releases. So what remains are 2-band or 3-band rolling schemes. And for the same reason, the 2-band rolling scheme is preferred. At a significant strength, at a fairly high strength of 0.9, we found that the rolling scheme performs quite well. But we still don't cover all the time scales that we would like to cover, particularly as was highlighted in several white papers, including the white paper by Eric Belm. As a default, with the default strategy, with the default baseline, Rubin would be blind to time scales of about 7 to 14 hours. And of course, we aspire for Rubin to cover all time scales so that we can study and discover phenomena regardless of what the time scales over which they change are. So this is where the interplay with the internight cadence happens. We can shorten the time between revisits of a field. So we often referred in these slides to triplets. So that's the idea that if you take 3 observations in 2 filters, you're going to have both the color and the time scale for evolution of a transient, so long as the time gap between these observations are relevant to get colors. So you want those to be close by, and far enough to actually get leverage on over the time scales of changing of brightness. But the way in which there's multiple ways in which essentially triplets, this matching observation, this third observation on the field, in addition to the 2 that are default on the same night, can be added at multiple time scales at which you can add them. So what the SCOC believes is that we can find, and we might already have found, a sweet spot between rolling parameters and intranight cadence parameters. So right now, the recommendations is that triplets should be added with long time gaps on a fraction of the nights, but not every night. We should boost the visits at a 1-day interval, and we recommend a 2-band rolling early cadence, at 0.9 strengths. What we have implemented in version 2.9 are long gap triplets every 6 nights, 2-band rolling cadence at 0.9 strength, and one of the simulations has a roll early, so rolling starts early in the survey, which is coupled with fewer revisits on the same night. Altogether, we think we have found a really good solution that optimizes and maximizes a wealth of science. We are still tuning these parameters that I've discussed to really find what is the sweet spot. Let me go to the next slide, which is also about this. A couple of other considerations. The problem with the triplets is that they impact efficiency. So we're looking at a survey that doesn't have too many triplets at the cost of number of observations that you can take. Another concern that is brought in by forcing these third observations at a specific time scales is that you're forced to include observations that are a higher air mass than ideal. So you still lose some efficiency in terms of total depth of the survey and things like that. But this is good because this impact that we've clearly seen in our simulations from the efficiency from the slew time has allowed us to rule out a bunch of configurations and a bunch of possibilities that we had among the 500 simulations in version 2.x of the OPSIM. And we are left again with the fine tuning of the long gaps and the you heard Lynn's referring to suppress, repeat, and at this stage, all you need to know about it is that it's kind of a way to implement a revisit at some specific time intervals, at some specific time ranges, rather. So what does that mean for input? We actually have a very significant wealth of input on these and science metric that allow us to evaluate and analyze this decision. So I think the owner of this decision resides primarily with us, the SCOC and the OPSIM team, to produce some more simulations that explore these parameters and their interaction and really find the sweet spot. But I want to emphasize that the rolling cadence subgroup and the intranight cadence subgroups have worked very intensely already. And I think all the simulations that have been produced as version 2.99 really do provide a lot of coverage for transient phenomena at different time scales. I'm putting here two of the graphics from Lynn's notebook that explores version 2.99. As you've seen before, blue is good, red is less good. Neutral is the first column, and that is version 2.0, the default baseline version 2.0, and everything to the right of it are subsequent simulations, version 2.1, version 2.2, and then the set of simulations that we have produced as version 2.99, the 4 simulations that we have presented yesterday. And here are some specific transient metrics. We have kilonova metrics that are tuned differently for the needs of the desk and the needs of TVS. We have some metrics that attempt to evaluate the ability to discover unknown unknowns. And we have just metrics that measure what is the time gap, what are the time gaps, so they give you an insight into what time scales are covered. So we have all the insight. I think we have all the insight, and I think it's a matter for the SCOC to work on fine-tuning the parameters to get to the optimal place. Right?
So I wanted where my SCOC have to say, I think we need to be clear that Presto Color is kind of off. The Presto Color simulations are kind of off the table because we know that they hit solar system very hard because, as you showed, they impact slew time. But as right now, right, what you're saying is being iterated on is not, is there going to be a switch back to Presto Color, which does significantly hurt solar system metrics and some others? It is the iteration of this long gaps sort of simulation. Yeah. I think that's, is that correct? Or just to give, I think, some perspective on that, because there's a lot of tension between those. I know you're showing the transient metrics, but the solar system is sometimes impacted.
Yeah. Sorry, there's perhaps a bit of confusion. So the Presto Color was an attempt to implement a recommendation to get triplets that was fairly compact and had observations strictly within the same night and sometimes in a very short time scales. It wasn't scientifically really hitting the goal of the triplets recommendation, and it does induce a significant loss of efficiency due to the extra constraint that you have on choosing the field of the sky. So those, as the Presto Color is implemented, those simulations are definitely not favorable. There are two kinds of simulations, if you're familiar with the OPSIM families in version 2.x that kind of get to the same goal in slightly different ways and for slightly different purposes, perhaps, but they still implement the triplets effectively. And they're the long gaps and the suppress repeat. And so the parameters that are included in those are the things that we're tweaking. And so, oh yes, and it's kind of incidental that this is also called Presto Color. Any other questions? All right, I think that was my last slide on the details of our recommendations. I hope I clarified where we are actively seeking input, where we believe we can come to a decisions, where we are not attempting to come to a decision at this time, and we're expecting to organize and come to a decision in 2023. The last slide, I just wanted to just clarify a little bit of the timeline. We have released the simulations at the end of October. Today, we begin receiving your feedback from these simulations, and I want to emphasize the word begin here. The liaison, as always, are available to support you and communicate feedback to us. I want to set up some kind of more direct contact point with the SCOC, but we are in transition between the present SCOC, which also has a fair amount of work to finalize their work before the rotation, and the new group. So what I've set up is an office hours that for the moment I commit to be at, and I invite all my SCOC colleagues to be at as often as they can, for people to just come in and talk to us, ask questions, or share feedback that they want to share in a direct discussion. I think I set them up at 11 a.m. Eastern. Did I say Eastern? Yes, I said Eastern. 11 a.m. Easterns on Monday, and I commit to be there through the end of the year. At that point, with the new members of the SCOC, we'll revisit the plan for this, and we'll find probably a different time where more SCOC members can participate. And I should say SCOC members and survey strategy members. And we are posting them. We've actually been doing, I've got several requests for this, and we've actually been doing it for several months of posting public minutes from our meetings. Typically, we post them about a week after the meeting, just because we take detailed minutes during the meeting, then I summarize them, then I share them with the SCOC and seek their approval if they reflect what actually happened in the meeting, and after that, I post them. It was a bit unfortunate that I posted them on what became a very long thread on community. It was the thread where we had announced the questions that the SCOC was pursuing. So I made a separate thread on community that is called public SCOC meeting minutes, that hopefully will make it easier to find. These are typically short meeting minutes, and the piece of text that got covered by that screenshot just says that when available on the same page, we will also let you know when our next meetings are. In some cases, we have meetings that are scheduled well in advance. In some cases, we are waiting for critical information to set up a meeting, including, for example, waiting for simulations to be wrapped up. And so the meetings get organized on a shorter time scale. That was the last slide, I think, that I have. And we do have 10 more minutes for more Q&A. I just need to find my screen. Here it is. Any questions or comments or suggestions? Absolutely. Any of the above. I see in the chat there is some discussion of parallax. And there were also questions specifically about parallax in the topics of discussion that you have proposed during the registration process. I don't remember the exact question. I have it on my screen somewhere, so I might be able to find it. I don't remember the exact question about parallax, but I think you will find that the current simulations have improved parallax measurements. And I know from some people in the community that have expressed that they were happy seeing that. Was there a specific question about parallax that was not answered yet?
No.
Okay. Does anybody that had suggested topics for discussion in the forum feel like I have not addressed their topic? A couple of people had asked about details of data products. Like I said, I'd rather not address it here, but I want to point you to Melissa Graham, who has office hours as the community engagement team, and she's an expert on these, as well as a few documents which I can then post in the Slack that have been produced and updated recently on data products. Anything else? If there's nothing else, we can perhaps break for our break a bit early. And
there's a question in the chat for you from Graham Smith.
Thank
So
you.
I think it's worth discussing.
Oh, yes, it is worth discussing, but I think I want to call on my DDF subgroup to answer that better than I could. What drives the choice of Cosmos for early achievement in 10-year depth if it only fills 10% of the LSST camera field of view?
Do you want me to talk about that a little bit?
Sure, Linda, that would be great.
Okay. So it is true that there may be other scientific drivers to choose than the other ones, but logistically speaking, from the scheduler point of view, Cosmos is separated from the other deep drilling fields. You saw how the others tend to align at this very already oversubscribed area of RA. And so from a scheduling point of view, it's far preferable to, because we have to take extra time to do that early achievement of 10-year depth.
Also, the Galaxy's science collaboration stressed that they would prefer Cosmos.
Yeah, there could be scientists, other science too, but yeah, for sure. And you're right, the Galaxies did say that one.
Yeah, and my understanding was, because I pushed on this, because I was like, I don't understand this. I do solar system. Why do you need this? Was that it's such novel science, like it's going so deep. LSST is that like a lot of the stuff that they are developing is like it hasn't been done. And so there's concern that if you don't actually have 10-year depth on something of a DDF early rate, you might tweak things or your analysis based on what you learned from that. And so part of it is getting that information so you can better optimize the other DDFs later, or raise things or new analysis tools you might need based on actually having data to that, which I bought after being like, why? So it made sense, but sorry, I don't know if Sarah's here to explain, but that was it. I accepted the answer they gave about that.
Yeah, very well said. I think that was exactly my understanding. Two new messages. Thank you, Knut, for confirming. Nothing else? In that case, we'll see you in 20 minutes instead of 15, 19 minutes instead of 15. At 10:45 Pacific is when we start your presentations. Again, if you haven't checked it yet, check Slack for the order in which we will ask representatives from the breakout rooms to present. And I look forward to not speaking for a few minutes, but I'll be here for most of the break. If you want to talk to me, I'm happy to. Actually, Lynn, can I make you co-host like yesterday? I have to change building, probably during the break.
Yep, no worries.
Thank you. Did everything go okay on Slack? I haven't looked at it, of course, at all. Okay, you're the host, and I'll make everybody else that is on the SCOC co-host, just to be on the safe side, if you all don't mind. Franz, do you mind? Oh, I cannot, because now I made you host, so I can't do anything. I give you all the power.
I'll add some co-hosts then.
Thank you.
Who, what, when, where?
We're gonna make you co-host. I'm gonna make co-host all the members of the SCOC.
So we
But
can-
there's no action item. You're just going to be a co-host of the call.
Okay.
But Lynn has all the power. Hi, Simona, you here? Hold on, you're muted.
Hi, I'm very sorry I'm late. So
No, you're fine. So you're fine to be the second presenter?
should I speak now?
Oh, no, now we have I knew that we were going to get confused with the time zones with the,
Okay.
so you're early by half an hour.
Oh, fantastic. So could I kindly ask you to connect again in 1 hour? Because I am in the university and I take 1 hour to go back home.
Okay, so that requires me to change the schedule. I think that the person that I need to ask is the one that will present third, which is Timo, who definitely was here, but he might have stepped out. Let me see if I can get Timo on Slack.
Okay, thanks. Otherwise, I will connect with my phone and try.
Yeah,
to-
it's much less good.
But
for
it's
sure.
more comfortable from a computer to make the presentation because I can show you the Galaxy.
Yeah. If I can just make sure that I have somebody that is comfortable and has no constraints going as the second person, which is the placement, like the second presentation, which is the placement that you're not, I'm sure that I can find it. And I can let you go in a minute.
Thank you.
It's a bit unfortunate because everybody else stepped out for the break. But I'm sure they'll be back in a second. So 1 hour will put you towards the end, so I will just place you last, okay?
Okay, that will be also convenient because at that point I have time to go back home.
Yeah, so then
yeah.
why don't we do that? I'll figure out who goes second, and I'll put you as the last presentation.
Thank you so much, Federica.
Yeah, of course, no problem.
See you later.
Bye.
Bye.
Oh, Will, you're here? Can you hear me?
Yes, I can hear you.
Since I know that you are one of the people that is presenting, not targeting you, I swear, just because I don't know who all is presenting for which group. Could you go second? Because Simona asked me if she could go later, and now I have a hole as the second person, and Timo is not here to move him up.
That's fine for me.
All right, perfect.
That also means that we won't have our stuff pre-corrected by any other groups before we talk. So no, that's fine.
Less work to adjust, right? Okay. So
That's right. I can offend the other 6 groups before. No, that's fine. I'm happy to present then.
perfect.
I'll keep an eye out for the transition.
So SSSC, stars Milky Way local volume, strong lensing, AGN, TVS galaxies. And if the people that represent are here and have heard something that doesn't work for them, let me know.
Thanks, Fed. I'll be back in a few minutes.
Of course, very welcome. Lynn, I'm gonna change building. So I'll close this connection, but it should be no problem. And I'll connect on the phone in case there are emergency during my transit. We restart in 2 minutes. So if you are, if you hear me, but you're away from your computer, you want to make your way back.
I added the solar system slide to that consolidated slide file.
Excellent.
But
thank you so much.
Do you want me to do the screen share, or do you want to just do the screen share? Okay.
You can do the screen share. I think it's easy, and then if people wanna use the same consolidated, they can use the same afterwards.
Okay.
You should have no problems. You should require no permission, but just give it a try. And then Lynn is now the host, so she will need to help you.
Let's see.
Oh,
Yep.
Okay, and then if we go. So that's working for screen share?
Yep. It's not in presentation mode though. It's actually a bit weird.
Yeah, I don't think it's actually working. I mean, we see the Safari screen, but not the slideshow.
Yeah, I think actually
this is the part I was having some issues with, I think.
Yeah. Let's see.
Somebody in the chat yesterday had said that moving the window after you select it causes troubles. I don't know anything.
Let's try this.
Yep, that looks good.
Okay.
So we see the top of the browser bar, but that's it.
Okay. Yeah, so that'll be close enough. And then good. Okay.
We have 36 people. Let me send another blast. And anything else that I need to do other than telling people on Slack to come back? Can't think of anything else. We are recording, so it's 1 minute past the benchmark. So why don't you please take it away?
All right. So I'm going to start by giving the solar system. Oh, there's a hand.
Yes.
Allison.
Hi, just a quick question, Fed. The transcript, will it be available to me afterwards? Is this a printed transcript or just for?
I think it will be available, but I don't actually often use the transcript, so it's a Zoom question that I'm not sure about.
Okay, fair enough. I'll take notes. Thanks. Bye.
Yeah, take notes.
Thank you.
All right. So we actually had a short call on Monday this week with the Solar System Science Collaboration, and Tim very helpfully added who was here. And there's a link there to the slides. I also copied them here. Thank you to Meg for putting together the slides. I'm Kat Volk, member of the SSSC. So our top metric for the solar system has always been the discovery metrics for the various simulations. So this plot is just showing a couple of the baselines. So far left, everything's normalized to baseline 2.0, and then the 2.1, 2.2 baseline simulations, and then the 4 2.99 simulations. And these are completeness for a variety of key solar system object populations. And we're just showing here the scale, the bottom is only like 96.5%. So there's not much variation in our completeness metrics across the different simulations. So that's good. Here we go. Another one of our metrics is the light curve metrics. So this is the ability to look at brightness variations of these solar system populations over time. And again, these are normalized to the 2.0 baseline. And we can see that generally everything keeps getting better with the light curve metrics for these mostly inner solar system populations. And I guess I should mention the solid lines are our brighter populations, and the dashed lines are the fainter populations, so smaller objects. That's why they're a little bit more variable. And you can see here, certain of the 2.99 for some of the more sensitive populations can change quite a bit, but it's all in a positive direction. So that's looking good. Now, if we just quickly look at these again, now normalized to the baseline 2.2, We can see again, the discovery metrics are all fine compared to 2.2, the 2.99 for the faint populations go down a little bit, but we're only talking like 2.5%, so 1% in some cases. So, you know, that's kind of probably in the noise. Everything is looking pretty good for the discovery metrics still. The light curve metrics now normalized to the 2.2 baseline. Again, they're all looking pretty good. We kind of decided as a collaboration when we've been evaluating all of these metrics that, you know, we're happy with plus or minus 5% compared to the baseline, because smaller changes than that are going to be affected by other things that are unknowns or weather, that sort of thing. So again, here, everything looks pretty good. Only the low galactic plane survey, which as we discussed yesterday is kind of not really a real contender anymore, does significant damage. Everything else is more or less in the acceptable ranges and a little bit better for some of the bright populations. The low solar elongation twilight survey, which Fed mentioned earlier, is going to be implemented in the first year, dramatically increases the discovery for inner solar system objects interior to the Earth. So what's being plotted here is the discovery of inner Venus objects. And I'm not going to try to pronounce that. So formally the Vatiras. These are objects, you know, they're inside the Earth's orbit, so they can really only be seen at twilight. So it's not surprising that if you add a twilight survey, the discovery metrics go up hugely. So that's really good. And there's still some details to be worked out about that twilight survey. I believe the previous page only had morning twilight in that survey. So if you do morning and evening twilight, that can change. So the scale in this plot goes relative to the 2.2 baseline with no survey from 0 to 250 at the top. And these are, so, you know, huge variations still to be worked out in these inner populations. But it's good to have the twilight survey. So of course, you know, all the variations in the different surveys have changed the number or the amount of sky that is receiving a large number of visits. So this is just showing the sky area on the y-axis that is receiving at the top more than 750 visits, or on the blue line at the bottom, more than 825 visits. So those do go down a little bit, the 825 visits compared to the baseline for some of the new survey simulations. Which kind of gets to our first point here. You know, so the wide, fast, deep and the north ecliptic spur, which is important for solar system, has lost some number of visits per pointing in the new simulations. So if, for example, we go to the like 1 by 30 instead of 2 by 15 and we get all that efficiency gain, you know, it'd be nice if we could get a few more visits back in the wide, fast, deep or the north ecliptic spur. But generally the 2.9 all do quite well for solar system. We're not seeing any red flags. Everything looks pretty good. We are very happy about the low elongation twilight survey for year 1. And the reason that's so important in year 1, of course, is that we are worried about the upcoming satellite constellations that will be happening. I mean, they're already happening, but the number of things in low Earth orbit are going to be increasing over the course of LSST. And that's really why that's important to start in year 1, when that will be least affected. It's basically the interference is just going to go up over time. So we are very pleased with that. Of course, there's still some open questions like what happens when the TOOs are included. And it sounds like there are plans to help sort that out in the near future. One thing we would like to kind of keep reminding everybody is that, especially in the solar system, I don't know, it's probably true for the other science collaborations, is that this is a lot of volunteer work, as Tim had posted in the LSST community space. So the more time we can have to ingest any new simulations or just set timelines for providing feedback on drafts and simulations, the easier it is for us. Just it's hard to do stuff last minute because everybody's trying to fit this in around funded projects. But I think the presentation today really helped clear up like what input is being looked for and on what timescale. So that's really helpful. So we just advocate for keeping lines of communication open for that and posted schedules. And I think those office hours are also going to be great for that. Just so that we have we can plan ahead a little bit more on what feedback is going to be needed. I think this is the last slide, a few more things. We're wondering about kind of what kind of math metrics we might have for year 1. as we get incremental template generation and how that's going to affect the early science. Also interested in at least defining the process for the nano surveys, the very small requests that are almost like DD proposals. It's clear that we need to see what happens on Sky before we know how much time is going to be available for these sorts of things, but we could start to define the process now to say like who's going to evaluate them, what would the TAC look like? And then just finally, thank you so much to Lynn and Peter for all the help that they've given the SSSC with interpreting the simulations and all those sorts of things. So I think that is it for the solar system, but if there are any questions, happy to take those.
Sorry, excellent. Thank you so much, Kat. And also let me take the opportunity to again welcome Kat as a new member of the SCOC starting in 2023. Thank you for taking on this charge. There were a couple of comments on Slack, but I think there were more clarification. Meg, unless you want to speak to them.
Oh yeah, Meg made a comment in our plots. If you look at the slides in more detail later, the Jupiter Trojans are quite variable. So you'll see those go all over the place. That's not one of our more decision-making metrics because yeah, they're just extremely variable.
Yeah. And to the questions that you asked, can you put your slide with the questions back? I don't think I have answers.
Oh, this one?
Also, yeah, I don't think I have answers, and the answers would need to come from the entire COC and not from me, but just one. We do encourage people to continue thinking about maps and thinking about their science and thinking about how the science gets measured. The map can be used during operations. They don't stop being useful in operation. As it's been the entire time, it's hard to provide continuous support for the development and ingestion of math, because the same team that does that is Lynn and Peter, who also do the simulation and have the SCOC understanding the math and leading us to formulating recommendations, and also have another million hats in Rubin. So support. One shall not expect that if one day one decides to write a map, there will be support for them immediately available to write it and ingest it. But the process of writing the map is continuously encouraged. Meg.
I don't know if Kat wants to comment first, but I just want to say, I think you're misinterpreting what we're saying there. We're asking is, we don't know what we're getting in year one of LSST because we don't actually know how incremental templates work, right? So there's we're asking, is the scheduler team going to create something with map to be able to actually explain to us, like, so there's good expectations of when do alerts actually flow, right? How much solar system objects you'll get, how many solar system objects are going to be detected in year one through prompt products, where right now we don't have a good idea of that because we don't actually know. And so we're asking that, not that like we want to make a new map to do something totally different. This bit about how do we understand what's possible, so we all are on the same page, that people aren't like, it's day one of the survey and so alerts should be flowing every day. That's kind of what we mean by that. So I think you might have, or it might not have been as communicated clearly.
Lynn, I saw you popping up in the list, so did you want to take that? Yeah, good. Good.
Yeah, I'm happy to give a few words. I think the extent of so anyway, yes, this is in the works, is to understand what we're trying to do for early science and how we might need to change the scheduler or survey strategy, for example, if we do. Certainly, we actually have planned into like what we're expecting to do next year is to do some work into understanding what early science might look like in terms of early incremental template generation. The uncertainty around incremental template generation involves a lot of things, and not just when we get the images. So it's there may still be some questions about that, but yeah, in general, I think that we will be having a look at that, and if there are specific things other than when do we get templates, that would be useful to know.
Yeah, I think one of the reasons why this would be useful to know is, again, as Meg brought up earlier, like funding proposals and observing proposals and stuff for everybody getting ready for LSST. Just having better ideas of what the numbers are going to look like for year one. So I think that'll be helpful.
Thank you.
Yeah, and I know understanding this is definitely one of the things that Leanne Guy is working on a lot as well. So.
And I think I sort of answered the question about nano surveys. This will be in operation. So it will be for SCOC 2023 together with operation team to decide schedules for those.
Yeah.
Thank you. Thank you so much. And perfectly in time, we can switch to not galaxies because I moved things around, but stars with local volume. Thank you again, Kat.
Thank you, Fed. This should be sharing my screen now. Do you all see the SMWLV slide in front of you?
Do. And I wanted to emphasize that you're probably going to say that, but just for transparency and clarity,
sure.
The breakout room, this is supposed to also talk to primarily or also talk about the breakout room yesterday, which was a merge of the Galaxy people from Stars Mercurial Volume and TVS. Is that correct?
That is correct. In fact, I was going to address that, but yeah, thank you for clarifying that. That's helpful. All right, thanks. Yeah, so as Fed indicated, this was quite a useful discussion, which, while I suppose topically, given the Stars Mercurial Local Volume title, we had really great participation from TVS interested individuals as well, and in fact, the solar system had representation there too. And in Igor's communal slides there, see a link to the live notes itself. So in this discussion yesterday, we covered topics that were sort of aimed at the things we were explicitly asked to talk about, which was how to optimize the use of the time spent to the galactic plane, including but not limited to the inner Milky Way. I should point out that everything I'm about to say, I'm saying with my SMWV co-chair hat on, and any errors I make are completely mine. People who were on the call can certainly correct me if I misspeak. So we broke the discussion down by spatial coverage and filter balance, which then I think culminated in the same action for the galactic science community. We discussed rolling cadences in the bulge to the extent that we could. And the fourth topic here was requested at the beginning of the discussion, but we ran out of time, which was to do with the total sort of time allocation to the wide, fast, deep like area for the inner plane, and that's going to be an ongoing discussion. So I've got one slide each that summarizes the discussion in these different topics, culminating in what I took to be the main actions for the group. So I'll go through them in turn. I should also thank Lynn for not only for all of the heroic work of the survey team, strategy team, but also for producing the figure on the bottom right there in the slide in response to our question at the meeting yesterday. And so just for those who haven't read this yet, this shows you a similar figure to the equatorial projection, but in galactic coordinates, which is helpful to those of us interested in sort of which areas are being covered where in the Milky Way. So the coverage of the galactic plane, which I know is not limited to the bulge, but latitude areas, has vastly improved over the various versions. So thank you very much to everyone responsible for that. The current coverage of the galactic plane is a compromise between science priorities as were gathered in a process led by Rachel Street and operational efficiency, in the sense that if a large number of known objects like clusters are chased, that can produce quite a patchy set of coverage of high cadence observations, and it's better to sort of dilate those together into a lower number of larger area regions. but indications from this are that the survey will likely be confusion limited everywhere, at least in the non-U filters. Much of the discussion we had about this topic focused on the spatial distribution of the green areas. So where do you really focus for higher cadence to do things like better froth motions, better variability, and so forth. And so the main question I got from the discussion was, are we happy as a community with the resulting coverage for galactic science with a big G? And I've put a couple of indications up on the slide here for sort of some of the ideas that were brought up. One in particular is that the South Celestial Pole, which is an area of interest for local volume dwarf science, could be improved, at least by allocating more feedback. The question then is, how do you do that within a sort of total overall coverage for the whole galactic plane region? It was noted that quite a lot of high cadence area is currently given to high air mass regions. I'm thinking in particular of the sort of, there's kind of a spur that sticks out in the lower diagram above the SCP region. That has high cadence, but is also a high air mass. We discussed this sort of dusty plane blob at negative galactic latitudes. The question is, right under the word dusty plane, on the figure at the top there, the question is, should that connect? Along with a sort of broader issue about whether should a survey really be as uniform as possible in terms of area? And so this topic and the next topic, which is filter coverage, lead to the same action for the galactic community, which is to produce a limited set of requests for OpSims to try and explore these areas quantitatively. So for the filter balance, on the understanding that the filter balance for the I guess non-extragalactic region can be different. As a community, we have to understand what we need to enable the most science here. And here, as well as with the footprint, I don't think we have a consensus yet amongst the SMWV and TVS and other galactic interested communities. A few indications from the discussion. We think we do have a consensus that we want to reach at least the confusion limit in at least the GRIZY filters everywhere. And there might be some room to tweak that for seeing distribution. For example, do we want to get a small number of great seeing to provide a legacy data set that goes as deep as possible? It appears that the more intensively observed regions tend to benefit from greater weighting towards the sort of middle 4 filters, as long as the confusion limit is still reached elsewhere, but that's also by no means unanimous. There's at least one science case that wants intensive monitoring in wideband. I point out that weighting to the middle 4 filters also emerged from the science case prioritization process led by Rachel, as you can see at the notebook linked here. And it was discussed the possible trade-off within GRIZ is there are some science cases that might benefit from weighing more heavily towards G-band, and the question is, where does that come from? So this and the footprint issue have, I think, the same action, which is the community should try to produce a specific limited set of requests to allow us to explore these combinations in a sort of metric-enabled way and try to do it on a timescale that the SCOC needs. And then the third topic that we squeezed into our discussion yesterday was rolling cadence. Quite a lot of the discussion, which I personally found very helpful, was the discussion about what galactic science rolling cadence actually enables. And I've put some of the indications I got from the discussion at the bullet points up there. With the caveat that I think the rolling cadence implementation in the bulge, for example, is still under development. I think I heard correctly that rolling tends not to improve most of microlensing science, particularly not planets, but short timescale events. One point did come up in the discussion, I think that's relevant for the whole room, is that I think some of the discussion about rolling in the inner plane interacts with the status of any intensive cadence observations that end up happening simultaneously or in cooperation with Roman or with Euclid. There was some discussion, I think last year, about a possible joint campaign. If that does happen, then that might supersede rolling cadence as the best way to get this sort of cadence intensive monitoring that so many science cases could benefit from. And so with the understanding that rolling, while very good for cases requiring high cadence monitoring, does tend to blow a big hole in coverage over the 10-year time baseline. The suggestion was floated that rather than trying to roll across even a big area of the inner plane, perhaps the best case for rolling in the inner plane would be to select a small subset of fields and use those to probe the underlying populations by characterizing short timescale variability for that limited number of fields. And questions of that include, well, how big is big enough? Are we talking 2 fields? Are we talking half a dozen? But it seems clear that this needs to be tested, and touch wood, should be, at least in principle, straightforward to do, right? We can imagine requesting a particular list of a few fields to be allocated rolling cadence in a particular way, and then just evaluate the outcome for what that does for the kind of population studies where the subset of fields explored at rolling cadence can be used to explore this sort of much larger underlying population that couldn't be done everywhere. So that's action 2 that I took from the meeting for the galactic community, is to produce that limited set of requests in a way that is reasonable for a SIMS team to actually implement and then run. So we can then assess it through the metrics. The figures on the right, I've just shown the same sort of equatorial map of the sky, with a selected N visits map from the rolling cadence version 2 notebook, just to illustrate some of this popping up of coverage that can produce for different reasons. So that's what I got from the discussion, and again the live notes are linked in the slides. I'm going to pause for a sec and allow anybody in the room yesterday to add any clarifications or comments that you might have, because it was quite a wide-ranging discussion.
Yes, if you were in the room and you have anything to add, please feel free to raise your hand. Rachel, but actually before that, I just wanted to make one point, which is that I define the galactic plane choices that remain to be made as compartmentalized. That's only true up to a point, right? So some of the choices you might make, and I think that includes choices about the connectivity, do impact the survey efficiency because they constrain the slew choices. And so you can keep it compartmentalized if you decide that you take the hit on efficiency exclusively within the galactic plane, but otherwise they would impact the survey altogether. And some of the things that you said, like some of the suggestions that you made, including like changes of rolling, I think might impact efficiency. So this would have to be one of the considerations that we make. And I just want to make sure that my definition of those choices as compartmentalized is not misleading in this regard.
Yeah, if I can respond to that quickly before giving Rach a chance to comment and correct me. Yes, we were thinking in terms of specifically rolling for subset fields within the the non-extragalactic region. But indeed, if this does lead to lack of impact on efficiency outside the galactic plane region, I would assume that would show up in the metrics.
Yes.
I mean, that's in some sense, that's the whole point of having metrics in the first place for everything. So
It would,
certainly we are not at the moment
choice.
attempting.
Yep.
Yeah, we're not at the moment attempting to sort of smash everyone else's sciences to study the Milky Way galaxy. We're quite sensitive to the idea that we want to do this in a way that doesn't, as much as possible, limits the negative impact on other science.
Okay.
All right,
Rachel.
sorry, Rach, you had a comment.
Hi, yeah. Just to point to some work by Lynn towards some of the points that you raised in not the current 2.99 simulations, but the set of simulations prior to that, 2.2, Lynn very kindly explored two different proposed regions, one of which was a smaller high cadence region. And we also explored two alternative sets of filter balances. So we have taken some steps in the direction of exploring some of the remaining trade-offs that need to be evaluated. As a result of the interesting discussion yesterday, I think a lot of that needs to be expanded, and it would be great to have a follow-up discussion with the galactic science community about expanding that simulation more deeply. But I wanted to make sure that Lynn's work was recognized, that she has already taken on some of those steps.
Yeah, thanks, Rach. I should have pointed that out, that we're not starting from scratch here by any means. Thanks to Lynn. Would you mind that effect into the live notes with links, if possible?
Sure, can do.
Great, thank you very much.
Are there any other questions or comments from anybody, including I want to encourage members of the SCOC if they have questions on this, of course, at this time. Meg.
Yeah, wearing my SCOC hat. I asked it in the Slack, but it's not clear to me what fields mean. When you say we're going to have fields that are rolling, when I first think of that in my head, I'm thinking of like a pointing, like a single LSST pointing. I presume you don't mean that, but if you can just clarify what you mean by fields in that case.
Sure, I think that's still to be determined by how. I don't have an answer for that. I suspect different people in the room might have different understandings of what that means. I actually was thinking personally of a smaller number of pointings, maybe a few pointings here, a few pointings there, to some number that gives a decent sampling of the underlying population one wants to get. But I think that's something that we should explore. And like in the discussion before, I think it'll come out in the metrics, the impact this would have on other science.
Thank you. Any other questions? We have 2 more minutes for this science club, for this group, if we stick to the 17 minutes per group plan. But if there are no other questions, thank you so much, Will. And I think we can. Oh, question. Did I hear somebody saying question? Thank you, Will. And next on deck, Timo for the strong lensing science collaboration.
Hey, let me see if I can track this.
Yep.
Does it work?
Yes. Good. Perfect.
Excellent. Okay. So I'm in charge of giving the feedback for our breakout room yesterday. The participants were, as in most breakout rooms, Lynn, who we appreciate her support. She's a representative in the SCOC and has produced a bunch of plots for us and helped us understand and drawn our attention to different things that we will mention here. So just to give a little bit of context, any strong lensing science will need strong lensing systems, okay? So we need to find these systems. And strong lenses are rare, so we always prefer a large survey area. Typical lenses are low redshift red galaxies lensing blue high redshift sources. So then we would need at least moderate depth blue and red bands. And one important thing to note is that we need them early, okay? I will talk later about lens transient science cases, but we need to build a catalog of strong lensing systems or strong lensing system candidates to follow up after the first or second year of the survey. Now, the separation between lens components is very small, so we need very high image quality, okay? This is something that we share with galaxies and with DESC for weak lensing, for example. But the thing that makes it different for us is that we need high image quality in the G band as well because of our blue lens sources, okay? And this is the concern that we have that I will talk again in the next slide. Another thing that arose and that will be also discussed by DESC is the fact that these rolling cadences, to which we have some problems that we will see in the transient science cases, also now that I didn't know about it, but there's an issue of the uniformity of depth, okay, due to the rolling cadence, which is also a problem for us because we need to understand the selection function for when we find our strong lenses, okay? Now, and the last point here is about the fact that we need these candidates early, okay? So we already have approved survey to do fast spectroscopy with the foremost on all of our lens candidates to confirm them. And then we will use LSST as a survey to monitor for lens transients within these lenses that we find early, okay? So and a lot of the static science, if you wish, is focused on the first couple of years of LSST where we will find our candidates. And now this is the plots that we have regarding the image quality. So as you can see here, we have in this plot, the seeing in year one, okay, for the G band and for the R band, both very important for us. And we can see that in comparison to the baseline V 2.0, we don't see much changes, okay? So it's not much worse, it's slightly better, one could think, but there's not significant change. But one thing that we are, again, a bit concerned of is that this is all compared to the baseline 2.0, okay? But baseline 2.0 already has a small hit on the seeing of the G band, okay, on the first year. So we're a bit concerned about this, and we just want to draw attention of the SCOC that please do not do not put the bad seeing nights on the G band in favor of the R and I. Okay, we're very interested in having good seeing in these three bands, at least the first year. Okay, and regarding transient science, this I'm talking here about two specific strong lensing transient science cases. There are the measurement of time delays and quasar microlens. So for time delay measurements, we do have a metric. It's an old metric and it's a bit outdated, if you wish, but it should give you an idea of how well we will be able to measure time delays statistically for all lens quasar systems that we find, okay? And ignore what they mean, but the important thing here is what is being maximized with respect to baseline 2.0. So you can see that most of them increase, okay? So there's a slight increase on the new simulations. And again, as always, you can see that rolling hurts us, okay? Rolling cadences in any of it, if their ways, I mean, their schemes will hurt us. So here, the two simulations that maximize the time delay, the high quality time delay measurements are the ones that are not rolling, okay? Now we do see an improvement even in the rolling ones with respect to 2.0, and I think, and please, this is something that Lynn draw our attention to, is that same night visits are suppressed, okay? And this is good for strong lensing science cases because they don't vary within a night, okay? So multiple observations within a night for the transient science cases of strong lensing are not important. So putting the observation in another night, it's always better. Anything that goes closer to uniformity is better. And on the right here, you're seeing a very old simulation, but this is just to make the point again that rolling cadences in general hurts us. In quasar microlensing, very similar to time delays, the scales are very variable and they can happen. You don't know when they're going to happen. So anything that goes away from uniformity is not very good. So the milder the rolling cadence that will be done, the better for us. Now, regarding the new implementations, these are the different time delay metrics. Unfortunately, we don't have a microlensing metric because to generate this plot for one system, it takes like 7 days. So it's not something that can be implemented quickly into the map. But regarding the time delay metrics, you can see that with respect to baseline 2.0, everything is basically increased, okay? So the new simulations in comparison to 2.0 are better. On the top here, you can see also the total length supernova that we're expected to find, okay? This is also a transient science case. And you will have more details of this in the desk discussion because Nikki Alense and Suhail did a more advanced simulation than the one that I'm showing here. Now, lastly, I just wanted to advertise, since we talked earlier, Fed talked about TOOs, that there will be also a strong lensing TOO proposal, nano proposal, and this will be for lens gravitational waves. Lens gravitation, LSST, I mean, we tick the box of being unique because the depth and the field of view of LSST is the only one that will allow to actually see lens gravitational waves. And one thing that I want to draw your attention to is that they are quite different from the normal gravitational wave electromagnetic counterparts. First, because the selection is very different. They go into the mass gap between black hole mergers and neutron star mergers because they are magnified. And the selection is quite different. We don't need to get colors of the field, but we need to go deep in one field. Why? Because the other selection that we do is selecting basically these gravitational waves when they're happening near a lens that we've already identified in the first 3 years if we have good seeing. And the drop in magnitude is significantly faster, okay? Just because they're being lensed, okay? We're looking at a different rest frame, so the drop is faster. And again, for this science case, as I told you before, we rely on knowing the lenses beforehand and understanding the selection function that pulls into the uniformity tab. So in summary, what we discussed is that, as always, we want early image quality. We want to, again, stress that we need it in G-band. We see that the G-band is slowly worsening on the different simulations. And we are concerned about dumping the bad seeing into G, okay, in favor of RNI. Rolling cadences, besides being not so good for transient science cases, because we have rare systems and unknown timescales, they might also impact us regarding the uniformity and then understanding our selection function. Now, going back to the transient science cases, the later sims seem slightly better, and I think this is because of the suppressing of thermal visits. And again, transient science also relies on this thing that is generally not thought about because it's not a transient science case, but it's of the fact that we have a catalog of strong lensing systems, so we need to find them first. So that's it. If I said something wrong, please, anybody that's named in my presentation, correct me.
Thank you, Timo. You're all doing so good with time. Thank you so much. Lynn, do you? Yes, thank you.
Yeah, sorry, I see Knut has a hand up too.
Yeah.
So
go ahead.
I was gonna say, as of V2, we did add a good seeing requirement, but it does run in GR and I bands. So basically we're trying to get 3 good seeing images in each year in each of GRI. It's possible that, like, I know Timo actually asked me to change that plot. So instead of looking at the median seeing value, it was the minimum or the median minimum. And I haven't sent back a updated plot of that. So I don't know actually what it would look like if you're looking at the minimum instead of the.
I don't know either. No, so yeah.
But it is also possible that we need to go through and check that all of those parameters for like looking for the good seeing in those years is set as we would need it to be.
Yeah, I'm just saying that please do not forget when optimizing scene that G is also important. I've heard a lot of talk of optimizing RNI.
But so
Yeah,
far there
definitely
have not
there's
been.
emphasis on RNI, but we did have G in there as well.
Yeah, to be clear, so far there was no deliberate attempt to optimize scene for RI and not for J. Although, you know, simulations are complex and things might happen sort of accidentally, but no deliberate choice of the SCOC based on that at all. Knut.
Yeah, so I just want to check an interpretation. So your metric plots basically showed all of the sort of the recent simulations in the green zone. So I mean it looks like all of the considerations being discussed are either good or even better for strong lensing science. And if the principle remains to minimize unhappiness, would it be fair to say that strong lensing is the group is uniformly happy with most of the choices being discussed?
Thinking that there will be a rolling cadence, yes. I mean, for a rolling cadence, this is not the worst possible scenario. So that's what I would say. But this is for the transient science case. So we have two science cases, finding lenses and then looking at variations within these lenses. So there are two sides to the story. So if rolling cadence might affect the selection function, for example, the depth of the scene, then it will in turn impact these transient science cases that are optimized here. So yeah, you're right.
Yeah. So and yes, I think you can see from the metrics that there is impact, but it's not. It doesn't destroy the science.
No.
Yeah.
It just makes it slightly worse if it's rolling. Well, and one caveat,
or slightly less optimal, maybe.
One caveat. So all these transient science cases that I'm showing you here, both the time delay metrics and the quasar microlensing, this is taught in a statistical sense regarding all of our lenses. Okay, rolling cadences might be better for specific lensing systems. So, for example, for quad quasars where we need fast measurement of time delays and they go within a season or within half a season. Okay. So this is only regarding the statistical thing. And I'm saying, yeah, so I'm saying here, particular scenarios still need to be explored, and we will, okay? So we will start new time delay challenges where we explore different techniques for fast varying things.
Thank you, Timo, for presenting this. And also, I want to, again, welcome you in the SCOC 2023. Thank you for taking on this charge. And if there are no further questions for Timo, goes in 3, 2, 1. The next on deck is Franz, who's speaking for the AGN breakout room.
Let's see. Slideshow? Sure, why not? Okay, can you hear me?
Yep, all good.
Good. Okay, so AGN Collaboration had a small group that showed up and discussed things. And so there were sort of 4 of us, and then Meg showed up and Allison showed up and hung out for a little bit. And so this is just an overview of kind of what we discussed. We don't have that many metrics. I think we have of the order of 4 principal metrics, and they are largely focused on, I think, old school AGN science in a way, just in terms of things that are kind of known with quasars that people have already studied. And so, you know, we looked at how they performed and had some discussions about possible extensions of the metrics and things like that, to try and at least gauge how we think some of the science will probably progress in the LSST era. And so just to summarize, we've had previous reports that Fed did not note in her main talk yesterday. And so just to highlight, these are our metrics for the different bands. And so in general, we don't see very strong variations, right? You know, sort of few % variations for most of the metrics for most of the new simulations. In one case, there's a really good benefit for the 100-day lag in G-band, but other than that, they're all pretty mild. We do take a hit for several in some bands, and then benefit in some bands for the 5-day lag. I suspect that as we optimize the few day sort of triples, that thing that region of sort of 1 to 2 day space, parameter space, this will improve. So I'm not too worried about that at the moment. The U-band in general is a little bit worse, but that's been known for quite a while, and that's just the fact that the U-band's in the filter set, the filter wheel, for only a fraction of the time. We also checked the DDF season lengths, which varied from something like 140 to 200 days. Typically, we want something around 200 days, and the average of there's only one field at 140. The rest are all above 200, so that's pretty good. This is matching the reverberation campaigns that are going on, or plan to go on in the deep drilling fields, and those are typically about 6 months time. And so ideally having 2 weeks before and 2 weeks after helps to track the continuum with the spectral changes. So again, we're pretty happy for the most part, but one thing that I noted was that basically the metrics we have designed have been mostly on pre-elasticity knowledge. And so as we skew towards the unknown, that typically skews towards lower black hole masses, potentially lower accretion rates. And so those would end up being shorter timescales. So we don't have many metrics other than, say, the 5-day metric that specifically probes that, but we think that probably we're a little bit safe because we can piggyback off of some of the concerns of other science collaborations that are stressing shorter time scale coverage. And so hopefully that will ultimately benefit AGN science in the breadth that we're looking at. Another important aspect that we discussed that we don't have a constraint for at the moment, or well, we have the season length that we've been looking at for the DDF. We could also look at it for the wide, fast, deep. I think the average for wide, fast, deep is more on the order of 140, 150 days, but Lynn can correct me if I'm wrong. And maybe one potential low impact strategy would be to sort of have, instead of an accordion cadence, which is what had been proposed before, have something like a sort of logarithmic extension. So we just have a few exposures at the ends of the seasons to kind of extend them by a couple of weeks. And that might be interesting for a few cases without having any real strong impact on the overall survey, because it'll end up being a relatively few number of visits. So that's basically all I had to say. I wasn't going into any of the science, mostly it was just sort of a summary of what we've been talking about. So I'll be very quick, okay?
Awesome.
Questions?
Thank you so much, Fent. So first of all, many apologies if one of the reports didn't make it on the list that I showed. I ensure everybody that it made it on the desk of all the SCOC members. It's entirely my fault. It wasn't neglected by anybody but me, and I'm very sorry about that. And I do have a question, actually. So because I want to recognize and acknowledge that the AGN community had done a tremendous amount of work thinking and advocating for the deep drilling fields, and sort of early on thinking how do we optimize the science in the deep drilling fields, spending resources and advocacy on collecting data sets, etc. And so I want to make sure that and there were white papers from the community, but I want to make sure that they feel like their voice is heard, whether or not their opinions were expressed through metrics, which I understand wasn't always the case, perhaps.
Right. So what I mentioned about the season length, I mean, we don't really have a metric for that, although Lynn kind of produced, there is a season length metric that's just a generic season length metric. And so we could use that as a proxy for some of these things. And the white paper in particular that this advocated for an accordion cadence was focused on that specific aspect of maintaining a long season length so that the light curve could be tracked in conjunction with the reverberation mapping programs, because the typical timescales, you have the disk varies, and then maybe on a say 1 week time scale, that will propagate to other cooler portions of the disk. So you have disk reverberation mapping that would happen, and that's on a short time scale. And then it would propagate out to the broadline regions. And depending on the size of those, which is scaling with the luminosity, you would have a certain time scale that you would probe for, say, H alpha or H beta in that ionization zone. And then you have a certain region for magnesium 2, a certain region for carbon 4. And so typically those timescales range from the order of like 40 days up to 200 days. And so the idea is that by maintaining the really long season lengths, you're able to capture more of those, right? Because at the longer timescales, if you might find a variability event early on, and you want to track it by the end of the season.
But you do feel like that can be incorporated into our process of decision, even if
at the moment we're keeping track of the season length, and it seems to be okay. We don't have a specific metric that says like, AGN season length.
No, right. But the SCOC doesn't only use metrics for its evaluation. Metrics make our life tremendously easier, but we do have panels of experts precisely to capture what's not captured in the metric or what's hard to interpret in the metric.
Yeah, so I feel that the need behind, say, the accordion cadence is being met. And so, there still could be some, as we are, particularly for the DDFs, as we're talking about like, this give and take with desk, to try and go much deeper for supernova at redshift 0.6, for instance. I think there may be a concern about if we start focusing a lot of the visits to the interior portion of the season, we want to just make sure that we still cover with some cadence the exterior portion, and whether that is in a logarithmic or in a linear way, that's I think still under discussion. Does that make sense?
Yes, thank you, Franz. Any other questions for Franz? We're still doing really good on time. I see Humna is already ready, but we do have some more time if there are any questions. But if there are none, we then can proceed with the presentation by the desk. Humna, take it away. Thank you again, Franz. Sorry, and thank you, Franz, for being a member of the SCOC and staying on the SCOC for 1 more year, exceeding your 2 years mandate to provide continuity in the committee. Thank you very much.
Sorry, can you see my slides?
We see it. It's not in presentation mode yet.
Okay. Okay. Great. Yeah,
it's still loading. We still don't see it. It might be what was happening to Lynn yesterday.
Well, we still don't see. Okay.
We do see the slides, and we saw it when it was outside of slideshow, but now it just says loading.
Yeah, it's not doing it.
It worked for a moment.
Yeah, I mean, we could also just have it without the actual slideshow. I mean, that's not terrible.
Yeah, if you put it in full screen and you remove the side on the bar, it's basically the same. So that would mean go to view.
Yeah, why would it not work? It's always worked before. Oh, there it works.
Now it's working. It worked.
Okay. Okay, sorry about that. Thank you. So I'm Hamna Awan. I am one of the co-conveners for the Observing Strategy Working Group in Desk. So I will be summarizing some of the discussions that we had yesterday in the Desk breakout group. I want to highlight that it wasn't just attended by Desk members, there were other people, and that was really exciting. So some of the things that you'll talk about will be because specifically of that as well. So just to kind of set the stage, we did not get to the Astro notebooks because we had so many people online who generally would not be together in one room. We took the opportunity to have discussions sort of on a non-simulation level base. So we decided to talk about what we're happy with and then what things we are concerned about and like how to go forward. So that's sort of the theme. We did not actually get to the actual simulations, and that's something that's on the to-do list for desk. And hopefully we'll be able to send a report in the next couple of weeks. So just to highlight some of the things that desk is particularly happy about, and thanks to SCOC and Lynn and Peter who've been awesome. So we are really happy that we are where we are now. So specifically to highlight for wide pass deep, we are very happy about the low dust footprint and the fact that different parts of the survey are being optimized differently. We're also happy with the pair visits and different filters. We are happy with rolling. Largely it works really well, and that's something we'll come back to in a bit. We're also happy with suppressed repeat visits. For deep drilling fields, we are happy that SCOC is recommending more than 5% of the time, and that's something that we have been pushing for, and that's something that's important for us. Another thing that we're happy about is the Cosmos coverage will be moved up early in the survey. I think this has been talked about already. It's great for static science, transient science, not just desk, beyond desk, right? So things that we are concerned about include the wide pass deep rolling and what that means for non-uniformity. And this is something that that has been sort of addressed a little bit or highlighted a little bit already. So I'll talk a little bit more about that. We also are thinking very specifically about the DDF details, and I'll try to give an overview of that. And also the thing that I will not discuss in detail, but something that we would like to continue working on is the synergy with DESI. So just to kind of briefly overview, DESI 2 could have LSST imaging samples, LSST imaging for its target samples, and that could be really great for not just desk, beyond desk as well. Because it's not just cosmology that will benefit from that. Because DESI 2 is going to be really early in the LSST survey, that's something that needs to be figured out, how it will work, depending on when LSST starts, how rolling will impact it, and so on. So I know that conversation is happening, and we are keeping an eye on that. So that's something we're concerned about as well. So just to talk a little bit about rolling, rolling and non-uniformity. So as I mentioned, rolling does help for most desk transients. So, better light curves, better photometric classification distances, strong lensing, for instance, presents a trade-off for us. So, here is a slide from Nikki and Sohail, where you see what happens, for example, two-band rolling and versus non-rolling. So you see that if you want a better sample light curve, of course, focusing on the active region of rolling helps, but at the expense of the number of objects that you see, right? So depending on your science case, you may prefer one over the other, right? And that's sort of the trade-off that we're looking at here. I'm not going to go into more detail of this work. This is work in progress, but if you're interested, please reach out, and we'll be happy to engage on that front. So yeah, transients are really... Yeah.
Can I actually ask a question for clarification? Do you have any more information about... Oh, it's rolling version 2.0. Okay, thank you. Sorry.
Two-band baseline. So we have now looked at other things. Yeah.
Thank you.
That's the thing in progress. So transients are really happy, are mostly happy for desk, but it complicates the case for static science, right? Because we want a high level of uniformity, not just a year 1 and year 10, which are not really the problem, but at intermediate years. So just to sort of really demonstrate this point, right? So I created these sky maps for I-band 5 sigma co-added depth with dust extinction. So on the top is the no rolling case, and on the bottom is the 2-band rolling case with, I think, 90% background. This is the baseline 2.0. And as you can see, things look pretty consistent between no roll and rolling, top row and bottom row for year 1 and year 10, which is the first column and the second column. That's great. But what happens if you look at year 2 and year 3, right? Suddenly we have these stripes, and that's expected, right? Because the fact that we have a 2-band half sky rolling. But this complicates the analysis, right? We cannot really do analysis when we have this high level of non-uniformity, because, for instance, it complicates shear measurements, it complicates how we deal with the depth mask for LSS studies. And this is something that goes back to what I think strong lensing folks are also mentioning, that this uniformity is in early years, especially when we are going to be writing a lot of papers of of more immediate impact, the things that we are planning right now, that this is something that's becomes really critical. So just to kind of like, so basically we were like, okay, we have to understand and decide the rolling parameters very carefully so that we ensure what we do between year 1 and year 10. And I'll talk a little bit about some of the things that we think that will be good to try out and explore. Now, just to kind of highlight, because this is something that keeps coming up, some may view this as a data management issue, right? If the DM can produce uniform coads at every time there are data releases, we are happy, right? But if that is a big if, right? That is a conversation that needs to happen, and we need to make sure that the uniform coads are guaranteed with every data release where we plan to do science. Otherwise, our science will be very difficult, not to mention that it will impact the field because the science will become so narrow that like it will be just very difficult to train, and new generation of astronomers and cosmologists. And that's something to consider. Not to mention, of course, the impacts in astronomy and photometric calibration, because, those are things that we don't always think about. So these are things that are really critical to actually consider as we are thinking about rolling. So sort of the point that we all agreed on is that DN capabilities are something that need to be figured out before deciding on rolling parameters. Before we say 2-band rolling, 3-band rolling, anything, we have to first understand what are the constraints from data management itself. And, again, as I mentioned, this is not just a desk issue. This is strong lensing galaxies. At least the 2 collaboration that we know have this requirement. If there are other science cases that do that, that would be good to know as well. So just to kind of go back to this idea of like, what rolling parameters can you consider, right? So for instance, right now we are talking about 2-band rolling consecutively, 2-band, 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 right? But if we know that, DM can produce coads or not produce coads, we can think about whether we need to pause rolling, right? In order to gain back the uniformity that would yield a uniform coad, right? Assuming DM cannot produce coads, uniform coads on it without that. Another aspect, for instance, is the non-binary view of rolling parameters. So not just saying 2-band for the entire 10-year survey, right? But if we do 2-band, 3-band, 2-band, right? Depending on when the data releases are going to be. So I feel like these are 2 of the axes, at least, that will be really good to consider as we're thinking about rolling. And just to kind of like highlight this impact of the pausing in between rolling, this is a slide from Matt Becker. So I'm just going to focus on these plots here. So on the x-axis is the year. So as the year is progressing, you have basically, more visits. On the left panel is the RIZ exposure time. That's the exposure time, and RIZ are the bands for shade detection. And on the right is the scatter in this exposure time. So to highlight here, the dashed line, this thick black curve is the no rolling case, right? And as you see, the blue, which is the rolling scenario. Oh no, blue. Sorry. The dotted black is a rolling scenario, and you see that, as expected, it actually goes up and down, right? Because it's rolling. That means that, when we actually if we want a data release at this point, it's not going to be good, right? It's not going to be uniform. But if you induce a pause, a 1 year or so pause, then we actually gain back the uniformity. This is the point that I was making before. And same thing, it also helps with gaining back the scatter. So this is just an example of, where you can induce like actual pauses and make it be uniform. And another thing to try is not doing just 1 year pauses, because I think here it was just 1 year, like whole year pause. We can try something shorter. Just an example of like what could be more interesting to see, and this is something that we would like to see going forward in simulation. And then to switch gears a little bit to deep drilling fields, just to highlight, so far, desk constraints are motivated by supernovae, type 1a supernova cosmology, and the metric specifically requires 4 epochs before peak and 10 after. It's a strict metric, but that's the metric that we have currently, and that's the one that we are going for. And then here's a plot from Philippe Grace, where you see the 2 metrics, Z complete, which is the redshift completeness, and NSN, which is the number of supernovae that are well sampled up to this Z complete. And as you can see, most of the simulations are not doing that well. We would like to be on this top right corner, but some of them are really doing poorly, some are not, right? And here I've linked the report that we sent to SCOC a few weeks ago, on this specific thing, right? And we think that there are axes that can be improved in the simulations that can really get us up here. The report includes specific simulations, but just to highlight a few things, 3 high-level requests, increasing the DDF allocated time, early coverage of Cosmos, and then dark time U filter swap with Z, because currently what's happening is that every time Z is swapped out, which is not something that's good for our metrics. First 2 are already included in V2.99 suites, which is great. And we heard from Lynn and Peter yesterday that the third is possible, so that was exciting to see. Some other things that we would like to kind of like play around with and optimize and consider is like ensuring, DDF scheduling minimizes long gaps, because that really hurts the science, right? It does not lead to like a good sample for us. Ensuring that the visit sequences in a night are optimized to make sure that the filters that we are requesting are there. Improving cadence by splitting filters and visits, so quad sims already exist, and that's something that we would like to continue seeing and analyzing. Improving cadence and depth by rolling non-Cosmos fields. So this is something that we specifically request in the report as well. It would be good to actually see what happens if you roll 1 or 2 DDFs each year. And then finally, consider the XMMM LSS as another ultra deep field, right? Because that also has spectra, and just like Cosmos, it will be good to consider optimizing that with that specific context in mind. So just to summarize a little bit and also add some new things, key takeaways from the breakout. We are generally happy with the excellent improvements in observing strategy from V1 simulations. As I mentioned, survey uniformity is a really critical thing. In the breakout, people, pretty much everyone was like, it would be great to have like a succinct report on this that highlights this important need, so that SCOC and other stakeholders can kind of back that. It's unclear who should organize this, so that will be something that I personally will be very curious to hear about. Like, what are people's thoughts? Like, how do we organize this going forward? Also, a related thing is it would be good to have no roll simulations for any major change, because we want to be able to compare that, right? If we don't have no roll simulations, it becomes very difficult to compare how rolling is actually doing compared to no rolling. DDFs, as I mentioned, need further optimization, but there is good progress, so we are happy about that. Other thoughts, it was great to get feedback from TDS, Strong Lensing Galaxies, and also SCOC members, where it was great. As I mentioned, DESI2 Northern overlap is really helpful, and that's something we would like to continue thinking about. As Franz mentioned, according style cadence for wide fast deep specifically also will be really interesting, although we realize that it might require extensive infrastructure development of the scheduler, but it might be something that is worth it. Another thing, as I mentioned, non-binary view of the rolling parameters. So basically smoother variations as a function of time and area as the survey evolves. I think this is something that SCOC is already realizing and thinking about, that we do not need to make decisions right now for the full 10-year survey. So keeping an open view about things evolving as the survey progresses would be great. As I mentioned, Desk has not yet analyzed V2.99 sims, but we are hoping to do that in the next coming weeks. So please look out for that. And then, we appreciate clarity on the timeline, because it becomes a bit difficult to really scramble, and that's not really the most exciting way to do science. Just to kind of also provide some links in case people are interested in hearing more, knowing or learning more about what we've been up to. So I've added a bunch of links here. Recent feedback to SCOC through our liaison. So there were 2 rounds of feedback on V2 sims and 1 specifically on DDS that I also mentioned earlier. I've also linked some of the papers so you can see how things have progressed. Also to highlight some of the recent publications, Lochner et al. Paper here, and that is in the special issue of AppJ. That is basically extensive details on what went into the previous work. And Philip's paper, it's got accepted, which is exciting. It talks specifically about optimized DDS strategy with supernova 1 and cosmology. Katrina Alves' paper that was on archive. It's on photometric classification of supernovae and analysis of observing strategy. And I think that the work is continuing on various fronts, including Nikki's work. And just to recap, sorry, really quickly, ongoing work, analysis V2.9 and SIMS. We are working on metrics to quantify the non-uniformity in YFAST by intermediate scales. We want to just make sure that rolling is not the dominant source of non-uniformity, because that is very difficult for us to do on various fronts. Impacts of rolling on lens supernovae. So that's Nikki and Sohail's project. Investigation of rotational divergence simulation. So Matt Becker and Eli Rykoff are looking at this because they're finding some strange stuff in View 2.0 since I think. So that's something that we are going to continue investigating and make sure that we understand what's going on, even though we know the final decision, the final system performance has to be waited for until commissioning. And then also we're working on photo Z metrics for DDS because that's another critical aspect of our science. Planned analyses, impacts of loosening the supernovae quality criteria. So as I mentioned, for DDFs, you want 4 epochs before peak, 10 after. So what happens if you want 8 after, right? We don't yet know what that does to our cosmology. So that's something that's planned, and hopefully we'll be able to deliver on that so that we can see how that affects things. Observing strategy impacts on photometric supernovae cosmology with wide-fast deep. So right now, we don't have metrics that are going from supernovae all the way to cosmology for wide-fast deep. So that's something in area of development. And then also, ideally, we would like a comprehensive DDF strategy. We have axes that we know that we want, but we do not have a strategy, and that's something that we are aiming for. And I think that's it. I'll leave my initial slide here just to kind of highlight where we are, and I'm happy to take questions. Thank you.
Thank you, Hamna. I already see a couple of hands raised. Meg and then Franz.
This might be a naive question, but sort of wearing my SCOC hat and maybe partially the science collaboration co-chair of all of the scale decisions have to sort of optimize as best we can and sort of evenly distribute the unhappiness. So I guess I'm trying to understand that as this non-uniformity and unhappiness, or is it really a problem? Because in my head, if you have a rolling cadence and it's 2 bands, once you complete it, you've got uniformity. So like year 4, you've got uniformity, right? So I'm trying to understand why is that and what is the issue with that? Because I would expect that every few years you get uniformity, right? Because you've sampled the whole sky and the same number of end visits. So why is it that once you've hit both sides getting the same number of end visits after we've completed a full roll on all the sky, why then can't you then do your science then? Other than I can't do it earlier. You know what I mean?
Parts of the sky are out of phase. You don't get to uniformity until you stop rolling because different parts of the sky are at different seasons. So the phasing messes things up.
So if you see here, and I'll let Matt also answer this because he's looked at this. This is the plot, right, where you see the RSZ exposure time. Is you can see the dotted line, which is rolling, does get back to the non-rolling case. It's just offset. So the data releases are scheduled at interval years, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, for instance, the first bump comes back at 3.5 years, right? That's when the server will be uniform, but that's not when the data release will happen. That's not where the co-ad production will happen. So that means that,
Matt? So look at the right panel. This is the variance in the RIZ exposure time across the wide, fast, deep footprint. And look at the dotted line compared to the dash. So the dash is a purely uniform survey. We do no rolling, which is not under consideration, but is a good baseline comparison. And you can just look at the regions where we roll, this dotted line, which is this variance, is always above the dashed line. So because of this phase issue, exactly as Peter mentioned, it never gets back to as uniform unless you put in essentially some gap time to let the fields that started rolling later essentially finish and let everything catch up. So that's what's going on in detail. And so these small little gaps between, so if you look at the blue line now, these small little gaps between the rolling cycles do a ton. You basically see that the blue line dips at year 3 and year 6 are now close in exposure time scatter across the survey at those intermediate years, as if we were doing a uniform survey. The other thing these gaps do is that if you're concerned about linking these different patches of the survey because the way that it goes up and down for calibration, these gaps will densely sample the survey across the entire thing, which could be useful for calibration tasks that link the entire survey together. So I don't think we know sort of in actual numbers how useful that will be. That's something that I want to get Eli to compute for us. But
so can I ask the question, which I don't understand is, yes, I understand there's non-uniformity, but in terms of all of your science, is that one paper or is that every paper you write? Because I would want 4 observations to do NEOs a night, but you're not going to get that because it impacts other science areas. And so what I don't understand is, you know, how does that impact that?
It's every paper. It's
every
angular
paper.
clustering. It's weak lensing. It's photometric redshifts. It's everything.
Thanks. That helps clarify it.
France and then
for the uniformity issue. So I mean, like, you know, you want to tie the entire sky together. For getting a uniformity at an early time, that is less scientifically motivated, right?
Why?
It depends on what you want to do. If you want to train new scientists to do static science, you need significant research projects every, you know, 3 or 4 years. So I think
over the
you have to
entire
ask a
sky,
question.
I don't think that, again, I don't think it's scientifically motivated. Versus,
I think that's a matter of perspective. That's a matter of perspective.
So I mean, if that's
one
wants
second,
to,
please. One
yeah,
second.
so
There is a scientific motivation for doing, and I think the motivation for doing it early is slightly separate. I mean, it is slightly separate from the scientific motivation. Not to say that there aren't justification or good reasons for producing certain science as early as possible. The zeroth order, you know, that becomes more complicated, right? If that impacts on other science that might also be produced earlier, if with other choices.
Well,
so I just want to push back
what
on that. There's no scientific reason. There are scientific reasons for doing it. There are additional reasons for doing it early, and which might not.
I am less convinced by cultural reasons, or, you know, sort of socio reasons.
Let's not, but let's leave it. I think what you meant to say is the science could ultimately be done, under both scenario, but there are other reasons why you may want to apply the scenario.
But the point here is that by doing that, you will also impact other science cases that can't do, you know, that will hurt other science cases,
of course,
for doing what we were talking about doing, which is getting uniformity in certain times.
And again, it's our job to balance this, but I just wanted to make sure that, yes, Hamna, I'm going to give you the microphone in 1 second. I just wanted to make sure that it doesn't look like we are ignoring the motivation, that it's urgent, because at some point it will be done, but it is part of the thinking process. Like, it's different if this can never be done, or if this cannot be done in the first 2 years or in the first year, etc. So, Hamna,
yeah, so I mean, year 1 is not the main issue, right? Because we never really start rolling before year 1. So I do think, like, I mean, again, the field is such that we have to write papers, right? Otherwise, we will not have funding, we will not have careers, right? And in order to enable that, in order to enable science, you do need data that you can actually use, right? And then if we are writing papers at year 1, even at year 3, you need significant data advances to make it worth it, because it's a huge collaborative effort, right? And that's currently the point. Right now, basically, we are not going to get to something that's uniform in the current scenario until very late, right? Like a few years into the survey itself, especially like if you don't add these gap years. I'm going to pass it on. I mean, I don't know if Saurabh, you have a comment on this, but Eric, since you're the analysis coordinator, okay. And then Hirani, I don't know if you have a comment on this.
I just want to be mindful of the time. We were a little bit ahead of time, so we can spend a little bit more time with you here, but maybe another 5 minutes, and then I'll pass it on to the next breakout room.
Yeah,
so
I don't know
I got confused about who wants to speak when.
Yeah.
I see in the order in which the hands were raised, I think was Saurabh, Eric, and Hirania, but
I still have my question.
Oh,
yeah.
Sorry, I
So
thought
Saurabh or Hirania, do you have comments on that, or?
Well, I just wanted to say that, you know, Meg, your question is spot on. It's also the question of what are the assumptions that are baked in from the DM side. So let's not forget about that. So the idea that the data releases have to happen at certain times. How baked in is that question? And then do the data releases have to use all the data taken up to the day before the data release? Or, you know, what is going to go into the data release? You know, is there flexibility to make it a uniform COAD, and would most people actually prefer that than to use every single visit, right? And so if the problem can be solved that way, then, you know, I think that would be the ideal solution.
Yeah.
Franz, you had a
yeah. So the other question was, you know, so in one of your last slides, you mentioned the idea of being flexible and kind of modifying things as we go, right? or being able to change the initial viewpoint. And I wonder, have you guys, because I think you guys are the most funded to do this and the most considerate of this, have you thought about how that will affect the selection functions? Is that an issue at all? Or, I mean, it definitely will, affect selection functions for transient sources. It probably is less so for the static. But, do you guys have some pushback internally from that?
I don't think that we have specifically talked in these terms, right? So far, we are still looking at it as an optimization problem. Let's see where we are. I don't think we are at a tension point yet, but I don't know, maybe Saurabh or Eric can comment on this. Yeah.
I was just, like for instance, with supernovae, we don't know exactly what the systematic floors are yet with wide, fast, deep supernovae. So if that's something we learn within a few years, that we're saturating XYZ floor, the photometric calibration or whatever it is, that would inform later on some things
within
like
a few years of actual real data.
Yeah, Hiranya?
Hiranya, yeah.
Yeah, I just wanted to make a couple of comments. Whoa, have I frozen? I just want to make a couple of comments about the uniformity issue. So, having uniform understood selection functions is absolutely critical, not just to desk, but I believe strong lensing and galaxies, science collaborations as well. So it's not an unhappiness thing, it's a deal breaker. However, it's quite possible this issue can be solved in software rather than hardware, as in optimizing the observing strategy. And I'm not sure this came across in the presentation, but one thing we discussed yesterday was that this could be brought up through SAC with DM to see whether the co-adding process can actually account for uniformity at the data releases. And Mansi was going to take that forward. And I believe she's already started doing that. I don't know if she's on, but maybe she.
Yeah, I'm happy to say that I spoke to Michael Strauss, who's the chair of the SAC, and he's going to organize a discussion between the DM and the SAC to try to get this a little bit more optimized for 3 different science collaborations that are pushing for it. So,
Awesome.
so at least the SAC has agreed to take this one on for the discussion with DM, and I think it's the appropriate body. And I completely agree with Hiranya, right? What we can solve in software with just timing the releases at selecting images, we should solve there, right? What DM can solve or what we can solve offline shouldn't impact survey strategy decisions.
Okay, that's great to hear. It's just, I think the critical point is that it cannot be on any collaboration to deal with this like co-edition, because it's computationally just absolutely infeasible. Matt, yeah.
Yeah, I just want to emphasize
this
that
will be the last question. We're running a bit late.
it's a comment. I just want to emphasize that survey calibrations cannot necessarily be solved in software if we haven't taken the data at the appropriate space and time intervals to tie parts of the survey together. So I think that's an important point that we can't lose in pursuing a DM-based solution to creating uniformity. If the rolling results in significantly worse sort of relative photometric calibration across the survey, then that would be bad for everybody. And I don't know if this has been looked at because I'm not in all these conversations. If it has been, then just ignore me. But if it hasn't, I think we should.
Thank you. Thank you all for the conversation. And thank you to the desk for the very well thought out and thorough presentation. And thanks, Amna, for representing the desk.
Thank you.
We have Igor on deck. Igor Andreoni. Do we have?
Hi, Fed, and hi, everyone.
Hello.
Can you see my slide correctly?
No, we just see the word loading again.
Oh, yeah, perfect. Okay, let me try one more time since it worked earlier. To try again. Nope, not share, sorry. Slideshow. Anything but loading.
Anything but loading.
Okay, third
Oh,
time.
no.
Last time.
In the interest of time, no. In the interest of time, do you want to just remove the sidebar and put it in full screen mode?
Yes.
So put it on full screen at the bottom of that list, and then click the arrow on the left at the bottom of the sidebar panel.
All
They-
right. Thank you, Fed. So I
And
would
this
like,
it's gone. Go ahead.
yeah, I would like to report the main feedback that we collected in a pretty small group that focused on the extragalactic transient aspect of TVS. So these people didn't quite discuss what's happening in the galaxy or for sources like AGN, but mainly about our ability to find transients across multiple timescales that happen outside our own galaxy. So I think the summary of it all is that all the metrics that we find most relevant have improved in the new baseline that was produced as part of the V2.99 simulations. Just to provide you with an example, for fast transients, we see improvement that go from 10 to 40%. Here, what's shown in this plot is the ratio between the metric result, the metric output obtained with the new simulations over what you obtain with the older V2.0 simulation for the baseline. So in particular, I think it would be good to stress the first one on the left, the first case of the draft connected V299, and the rightmost case, which is the roll early. As you can see, especially for fast transients, the roll early could be particularly convenient. For example, if you focus on the black dot over here on the top right, this is the ratio of the number of fast transients that we expect to be recognized as fast transients if we implement a roll early cadence. And in gray, you can see the ratio of possible fast transients that are present in the data. It's kind of the raw potential that we have. And as you can see, there is not a dramatic change with what's expected from the baseline. And this plot has already been included in a paper that hopefully will be submitted and then published on arXiv soon. In addition, if I manage to roll back, some of us noticed that also the number of visits for the White Fast Deep Survey has increased from about 750 to more than 800 as median value. And kind of going back to what we were saying about the rolling early cadence, what was noticed is that there don't seem to be there major setbacks for most science cases. In particular, one plot that we focused our discussion on for a bit is the plot that highlights the time gaps per band that the various cadences would offer. So if we focus here on the roll early, what we see is that there could be a dramatic improvement for most of the metrics and for most of the filters. One that would definitely get a hit is Y-band, but at least the people online didn't see that as a major showstopper, although of course we understand how in the near infrared there could be literally a lot of gold to find. We were even more puzzled though by the G-band, for which we noticed a bit of worse performance than expected, and in general the change of performance in G-band is somewhat the only action item that we identified to look into as a next stage. So again, other than that, we definitely wanted to say one more time how grateful we are for the SCOC to have found a possible good solution in sampling transient over multiple timescales, especially in the desert that was identified between 2-hour and 14-hour timescales. So it sounds like we're really going in the right direction. So since we agreed pretty early about all of that, what we did then was to join the desk collaboration breakout room and listen a bit to what their arguments were and try to continue a dialogue to understand whether the various science cases could agree or disagree about possible action items. The conversation, at least for the part that we attended, has been dominated by, has been concluded about the need for uniformity. And I think it's pretty safe to say that we, as people interested in extragalactic science, are totally backing the claims of our colleagues, in that we appreciate, first of all, how important uniformity could be for doing their science and to do it in a timely manner. And also how uniformity can help discover other type of transients that cadence alone could not address. On the other hand, we would be particularly happy if a solution in terms of software could be found such that the SCOC can have more degrees of freedom to operate with for specifically for determining the cadences. And as a reminder, every transient that is not observed is likely missed forever. So we find this particularly important. And that's all I have. Happy to take questions.
Thank you. Nice and compact. We get back some time. Questions for Igor? Perhaps is the G-band issue that you're highlighting, Lynn, this is the same, Lynn and Peter, this is the same that was identified for the strong lensing, or is it a separate G-band issue? I think it's a separate G-band issue. And do we have an answer on what drives it?
This is this slightly less depth in the G-band. So the co-added depth is less because we just get fewer visits. The individual image depth is a little bit worse in G-band in the 2.99 simulations, and I'm not entirely sure why. It could be related to the fact that the seeing looks, yeah, I actually don't know. We did it, and it doesn't show up in 2.2, so it is probably subtle.
Yeah, it is a very, I want to add, it's a very modest color difference. It's a very small, very small difference, but it's compounded with the fact that for all the other bands, it goes up, right? So I think this is an issue for us to investigate. Thank you.
Oh, sorry, the T gaps. Yeah.
Yes. Yeah, basically it's not performing much worse. Like if you look at the color, the fractional difference is really small, and this is also for the 1 day T gap. We were just curious about why everything has improved for the other bands and not quite for G. Perhaps it could be that the gaps were already pretty good as they were planned out in previous versions. That could be maybe the easiest answer to the question.
Yeah, and I think that that's one of the things like we can go and have a look at. There aren't as many visits in G-band, and there are, and so that it does tend to, there's interplays with how it's being paired with U-band or the R-band,
and it's possible that would be actually also a little bit noisier because there are fewer visits than the other ones. We are looking at a very small, very small decrease. Thank you, Igor. If there are no other questions, next and last but not least on deck, we have Simona May for Galaxies.
Hi.
Simona, and let me congratulate Simona, who's the new co-chair of the Galaxy Science Collaboration.
Thank you, Federica. So let me share with you the high-level criteria that the Galaxy Collaboration has worked in, and this is what we mainly discuss with Sarah, comparing the different scenarios with these criteria. We actually had some difficulties to translate the metrics for galaxies, the number of galaxies to this criteria, because number of galaxies is important, but actually what is more important is are those higher level things that are not necessarily visible on the matrix for galaxies. So we went through the different points. You see, the first point is the point that the desk already discussed in depth. So I won't say much apart the fact that we also need the uniform high quality data in the co-added data products. So this means that what's important for galaxies is not only the number of galaxies, but also the selection function, a very uniform selection function in the sky, not to have bias in the galaxy analysis. So it is important. And I've seen in the discussion on the Slack, something like you will have alpha of the sky or part of the sky, and will be useful to know exactly which part of the sky will be covered with which depth if you want more detailed comments on that. So the depth, the magnitude depth during the observations at significant times, I don't know, every 6 months, every year, or every data release will be really useful for us to produce more thoughts about that. Then the second point is the mitigate the effects of scatter light to detect low sulfur brightness objects. And with respect to this, Sarah thought that the 4 scenarios are pretty much similar, so we didn't have a strong preference for one or the other. And about the seeing, it was the same. So we have the RRM band less than 0.8 arc second seeing, so that is very good for us. And to attain the full 10-year depth in one of the deep drilling fields early in the survey is actually most of the scenario, apart the scenario where the coverage of the deep drilling fields is 5%. So that scenario is particularly not advantageous for us. We do not prefer it. And then we discussed the choice of the Cosmos field versus, for example, the Euclid Deep Field South, and we were wondering how the two collaborations will work together. Will work together in the 10-year span period, and if the depth of the LSST observation will match the depth of the Euclid observation to permit science at the releases of the two collaborations. The survey was extended in the Northern Hemisphere and Virgo cluster was covered. We realized that the U-band cannot be optimized. So we just dropped this criteria that is not really feasible in any of the 4 scenarios that you presented. So our main questions were obtain the magnitude depth for each release or each significant time period that you consider, I don't know, 6 months every year, every 6 months every year. We discussed Cosmos and the Euclid Deep Field South. It would be useful to have more information about the matching depth with Euclid, for example. And then we already spoke about the rolling scenario, so I won't say more than what the colleagues from desk have said. And then we discuss about the sulfur brightness fluctuation distance measurements. So that is with distance measurements in local galaxies. We were wondering how the cadence will bias this kind of measurements. So there are simulations to understand that, but we didn't have any strong constraint or message at this point about that. That was mainly our discussion.
Thank you, Simona. Questions for Simona? And sorry, let me point out, I forgot to mention it in my slides. Another recommendations that we feel that is to be considered final for from us is to include the Virgo cluster. So that has been recommended by the SCOC, or is in the process of being recommended by the SCOC phase 2. And more questions for Simona? Simona, I really appreciate that you were expressing like these sort of more subtle points that are not always captured in metrics. And I understand that not a lot of the needs of the Galaxy science collaborations are captured in metrics. So we appreciate the Galaxy SC and the Galaxy's XC and the Galaxy's community sharing their thought with us and helping us understand these points.
Yeah, thank you very much, Federica. Thank you very much for the enormous amount of work that you have done. I think, just explaining to Galaxies how to translate that in the needs that were expressed at the higher level is good. And Sarah was very, very useful to make that connection. So thank you.
Yes, Sarah is an outgoing member of the SCOC, and her shoes are going to be very hard to fill.
Yeah.
And yes, Jay pointed out in the chat, I can be more clear. The Virgo cluster inclusion is actually simulated currently. So it is a recommendation. It is already implemented in version 2.2, 2.99, sorry. All right, that was the last group, and it is 3:30. We have more time. We have some additional time specifically for sort of an open forum, more discussion, more in-depth discussion about the groups that have spoken on their needs. And after we have cut discussions off, in the interest of time, more questions to us, open forum, take it away. Does everybody feel like everything that they needed or wanted to be covered has been covered in this last few days? Oh, thank you, Maggie. Yes.
I guess my question is, where do we go from here? Because we can argue about cadence for like 5 more years, right?
Oh, we can. Sure.
And ultimately, we're only really deciding year 1 / maybe year 2, because there's going to be another SCOC review. So this is going to change. Like whether there's like a pause in rolling is like probably not even any of these SCOCs right now a decision, because it's going to change, right? Once we're actually in Sky. So I guess I think as a science collaboration chair, sort of wearing that hat, it still feels a little nebulous of what do we mean by 2023 and when the cadence is going to get decided. And I guess maybe this is a question for operations. When do you actually need this, like the scheduler team to be making the schedule to do, like finalize it and code it? Like, where is that deadline? Because I think it feels very nebulous of like, we could be going to next December, and probably that's not the case, but I don't have a sense. And so I'm wondering if operations can comment on like, where do they see they need things so that we know where roughly this, given I know there's not a timeline yet from the SAC of how their deliberations are going to go for next year, but are we going to be arguing about year 1 and whether that Northern Stripe survey is part of DESI? Are we going to be arguing about that, for another 2 years? Or are we, is that like going to be just have to be decided by July because the scheduler has to be coded and tested and run on Sky? So I guess if someone can give maybe any kind of feedback on where operation side of this is, of when their like hard deadline is for the year 1 recommendation.
So let me perhaps start to answer. Yes, I very much agree with you. We can we probably will argue about the cadence for the next 15 years, or I guess this is 12 years until the end of the survey. So that's a given to me. Just yesterday in the project science team, I pointed out exactly the need of this, like for us to get together with operations and construction and work backwards from their expected completion times, working backwards when the schedule needs to be available for the scheduler, and working backwards for us to make it. So that is a conversation that we are having, and we will have soon. And also I want to remind people perhaps that there is now a monthly updated, am I putting it on? I'm trying to put something in the chat, but also I should put it on Slack. There is a monthly updated forecast of the milestones that Rubin will meet through the beginning of operations. So we'll work backwards from that to see when our benchmarks need to be met and when the schedule needs to be ready to be implemented. Steve.
Yeah, I would just add that the ls.st/dates page We're updating the explanation, the text that goes along explaining the dates. Those, I think, simplistically should be interpreted as not earlier than dates.
Right.
Just to make it clear.
And it is, you know, because we are constructing and we update those dates monthly on the basis of, you know, how things go in that month of construction. Other questions or thoughts? If there is nothing else, I am happy to close the workshop early and give you back a little bit of time in your day. I'm also happy to stick around if anybody wants to continue talking. I really thank everybody that participated immensely and everybody that has participated to this workshop and participated in the optimization of the cadence in the past 7 years. It's been an enormous roller coaster, and I really appreciate everybody's time and effort and patience and interest. And I'm now Sians. Steve.
Oh, I just wanted to add thanks. I think it's just great to see. I know there are some natural built-in tensions. I think those can be positive and good. The paradigm of one data set serving all science needs is, I think, extremely important, extremely impressive, and the details matter, which is what's happening here. I'd just like to thank everyone, but I'd like to take the opportunity to thank Federica, especially for all of the navigating this very complex topic and getting this all together, and particularly facilitating the workshop in the last couple of days. It's just been fantastic and not easy. So strong gratitude. Thank you.
Thank you. Rachel.
I would like to second Steve's thanks to you and to the SCOC for everything that you've put into this, and especially Lynn and Peter for all the simulations that they have done so far, because this is a huge amount of work and a really groundbreaking effort to do a survey strategy. I had one question. One impression I got from all of the presentations we just heard is that a lot of us are going to leave this workshop and go away and do a lot more work on the new simulations. So what's the best way to share our feedback with not just the SCOC and the math team, but with everybody else as well?
So I think the best way to share your feedback more broadly is community. We're sort of slowly as a community embracing community as a forum, but that is the best way to post something that is visible not only to the SCOC, but also to the rest of the people that are interested. And on community, there is a dedicated topic on survey cadence with multiple, I might use the words wrong to describe the elements of community, but there is a tag survey strategy, which collects broadly all the posts that we have made over the years about the survey strategy, posts that the community has made about specific studies or specific considerations, the posts that Lynn has made, so many of those posts explaining all the 500 and plus simulations that Lynn and Peter and the observing strategy team have prepared, as well as posts by the SCOC. So that's a great forum to share information openly and transparently and broadly. Then, as always, you have liaisons in the science collaborations. I invite you to lean on the liaisons for a more direct question and answer about what the SCOC is doing and what your specific scientific needs are with respect to the survey strategy. And as I mentioned, I opened up this office hour. Right now, I don't want to put any more commitments on the SCOC since this need has occurred to me through recent feedback and the utility of these more open and direct lines. So at this time, I commit to be there. I invite my SCOC colleagues to come whenever they can on Mondays at 11 a.m. Eastern, and we'll see how we make that particular point of contact more operational and more sustainable in 2023 with the new and renewed membership of the SCOC.
Okay, thank you.
You're welcome. I don't see any more hands up. So if nothing else comes up, I again thank you all so much, and I wish you a happy rest of your day and rest of your week. The slides from today will be posted on Slack. The slides from yesterday have already been posted, and reach out and talk to us.
Thank you.
Thank you,
Bye.
Fed.
Thank you.
Thank you. Bye.
Bye.
Great workshop.
Was it okay?
Really good.
I'm a bit exhausted at this point.
Thanks, Fed.
Yeah, go get some rest.
Yeah, the compound effect of the two workshops, I think, will be felt.
Yeah.
Towards
And
the
jet
end.
lag.
And,
Yeah.
I think,
Take
you know,
care.
having a lot to do helps with jet lag, so I think I'm over that pretty quick.
Yeah.
All right.
All right, take
I'm gonna
care.
teach, actually.
Talk soon. Okay, bye.
Cheers. Bye. Bye, Alison. Everything okay? All right.
I'd love to ask questions, but you're tired. When would be a good time next week? Or
Sometime
you
next
want-
week, let's talk on Slack. Right now, more than tired is that I actually have to go teach again.
Okay,
but let's chat. Yes, absolutely.
that'd be
Cheers.
great. I'll
Good to
send you a
see
message. Thank you.
Bye.
Bye.